Start. कि तोड़ दो हर पिंजरा, मेरी उड़ान अभी बाकी है, मंजिल जमीन पर नहीं आसमान अभी बाकी है, लहरों का थम जाना नहीं समंदर की मजबूरी, बाहर खामोशी सही अंदर कई तूफान अभी बाकी हैं. Jai Hind and a very good morning to all of you. On behalf of Keral Verma Subharti College of Science, Swami Vivekanand Subharti University, I, Dr. Ekta Gupta, take this golden opportunity to welcome our Honorable Vice Chancellor Sir, Major General Dr. G.K. Thaplyal Sir, keynote speakers of today's event, Dr. Dilfuza Jaborova, then Dean Academics and Director Research, Professor Dr. Amar Prakash Garg Sir, IQAC Director Dr. Kapil, other members of IQAC team, Dean of Science College, Professor Dr. Renu Mavi Ma'am, faculty members, HODs and students to this one-day international symposium on natural agriculture for a sustainable world in hybrid mode that is organized by Keral Verma Subharti College of Science. Today, we are privileged to have with us some experts from various fields of academics who shall be reflecting on the theme of this symposium. जैसे कि हमारी देश और सुभारती यूनिवर्सिटी की परंपरा है, किसी भी शुभ कार्य की शुरुआत हमेशा ईश्वर के नाम के साथ होती है. Before we begin anything auspicious, we always light the auspicious lamp. May I request Honorable Vice Chancellor Sir, Dean Academics, Dr. Dilfuza Jaborova, and Dean Dr. Renu Mavi Ma'am, and other HODs to come forward and light the auspicious lamp. आइए चलें अंधकार से प्रकाश की ओर, पृथ्वी से आकाश की ओर, प्राणी से परमात्मा की ओर और अज्ञान से ज्ञान की ओर. Lamp lighting is supposed to bring a lot of positivity in the entire atmosphere where it is lit. Thank you all. एक और परंपरा है स्वामी विवेकानंद सुभारती यूनिवर्सिटी की, अतिथि देवो भव. We would like to welcome our esteemed guests by presenting them with a sapling as a token of appreciation. First and foremost, may I request Dr. Renu Mavi ma'am to kindly present a sapling to our Honorable VC Sir, Major General Dr. G.K. Thaplyal sir. Ma'am, please. Now, I would like to request Dr. Sangeeta Dayal ma'am to present a sapling to Dr. Dilfuza Jabarova ma'am. May I now request Dr. Amit Kumar, sir, to present a sapling to our Dean Academics and Director Research, Professor Dr. Amar Prakash Garg, sir. Now, may I request Dr. Vinay Pawar, sir, to present a sapling to IQAC Director, Dr. Kapil, sir. Thank you all. Thank you, sir. The International Symposium on Natural Agriculture for a Sustainable World is organized by Science College in hybrid mode. There are certain objectives. Number one, to upgrade the knowledge of students, research scholars on the variety of sustainable agricultural practices, to gain deeper understanding of the process, mechanism, develop data analysis and interpretation skills, and gain the ability to apply their theoretical knowledge into practices. The insights into sustainable agricultural practices will contribute towards understanding of scientific and industrial processes needed commercially. This program will benefit the students and research scholars of various streams like agriculture, biotechnology, microbiology, botany, chemistry, zoology from various institutes and universities. Now, this is my proud privilege and honor to request our Dean Ma'am, Dr. Renu Mavi Ma'am, to welcome our Honorable VC Sir. Ma'am, please.
Thank you, Ekta ma'am. This is my pleasure to introduce all of you to a person whose guidance works as a blessing for all the Subhartians. Our Honorable VC Sir, Major General Dr. G.K. Thaplyal Sir. Sir, we welcome you, please. Sir has over 40 years of experience in the armed forces and higher education. He has been conferred with various prestigious awards such as the Sena Medal by the President of India, Commendation Award by GOC-INC, Southern and Western Command, Lifetime Achievement Award by the Association of Oral and Maxillofacial Surgeons of India. Sir has been the head of maxillofacial team at UN Peacekeeping Mission Hospital in Cambodia, head of biomedical research team at Institute of Nuclear Medicine and Allied Sciences, DRDO, Delhi, professor and head maxillofacial wing at Armed Forces Medical College, Pune, Army Dental Center, Research and Referral, Delhi Kent, and many private institutions. With this word, may I request our Honorable VC Sir to shower us with his precious words and blessing. Sir, please.
Jai Hind. A very good morning to you all. Dr. Dilfuza, our guest speaker of the day and our chief guest for the day, Dean Academics, Dr. Amar P. Garg, our Director, IQAC, Dean, Faculty of Science, other faculty members from the Faculty of Science, my dear students, and of course, our two speakers who are joining us online, Dr. Binoy Chakravarti, he is the Professor and Project Director, Department of Fisheries, Bangladesh, and Sri Prasad Vista, Professor and Scientist, Nepal Agricultural Research Society, and of course, third speaker is our Dean Academics and Director Research, Professor Amar P. Garg. On behalf of Swami Vivekanand Subharti University, I extend a warm welcome to you all to this conference, which is an international conference and being organized by Faculty of Science in hybrid mode. I would like to first of all thank our esteemed guest speaker, Dr. Dilfuza, who has been kind enough to accept our invitations to be with our Subharti University for at least 1 week now and agree to deliver this guest lecture. I also thank all the guest speakers who are joining online from Bangladesh and Nepal. And of course, I thank Dr. Amar P. Garg, who is the key instrument, who is the main person who actually initiated this process and facilitated this conference. And I thank Dean, Faculty of Science, having taken it forward and with the Faculty of Science arranged this conference in a beautiful manner. I saw the brochure, nicely planned, and I'm sure this conference is going to benefit all students who have joined here offline and online. Just, I don't know much about what will be spoken in this conference, but to my understanding, what I can say, this is the subject as a well understood, not by many people, agriculture for sustainable, natural agriculture for sustainable growth. You must be thinking that nowadays for last few years, we have been listening this word quite often, sustainable development. Why we have started talking about this sustainable development recently? Why this word was not there in common about before 2012? 2012, when all UN nations sat together in Rio and they discussed about various issues like political issues, economic issues, environmental issues faced by the world, all countries of the world, including developed, including underdeveloped. Goal. And UN Sustainable Development Goal to achieve the time gap or the duration was given by 2030. Every nation should develop all these goals and achieve whatever the parameters, whatever the other sub-parameters are given in those 17 goals. But to our surprise, in 2021, when the audit was published about who has done what, the countries, and in that merit of countries, that order of the countries who have achieved how much, India was 128th. Imagine such a huge country of 140 billion people living in this country, India's 5th largest economy, and aspiring to become Vishwaguru, aspiring to become a developed country by 2047, coming in 120th position in UN Sustainable Development Goal parameters. So this was a kind of alarming, a warning for our all countrymen, particularly our government. What should we do? So they decided youth is the main force by which we can achieve these goals. Youth is the only, we should focus on our youth. We should focus on our young people. And where do we find the youth? Where do we find the young people? They are in the higher education institutions. So they focus, we focus everywhere that higher education institutions, if start contributing from their side, probably our speed of achieving these goals will enhance. And therefore, every higher education institutions were given the responsibility to contribute from their own side, and plus to sensitize and educate the youth mind, and not only their youth mind, also extend out this knowledge to the society through youth. How do we eradicate poverty? How we achieve no hunger? How we achieve the best health and wellness? How we improve the gender equality? How we work towards the environment? How we work about the life on the earth or life below the earth? All these parameters are there on the 17 goals. Out of all these 17 goals, higher education institutions not only focus on the quality education, that is goal number 4 or 5, not only focus on the quality education, but also on various issues related to environment, various issues related to social well-being, and other health-being areas. So in that process, Swami Vivekanand Subharti University, we started our own way of doing it. We allotted goals to different departments, different colleges. And we had given instruction or advised them to please carry out the activities under these goals and give us reports after every 6 months or after every 1 year. And based on that report, we will have a kind of a deliberations. We will think over what we have thought of achieving and what we have achieved. We will analyze those gaps. And again, for future, we will plan. I also advised all the faculty members, or particularly deans, to write their own point of view, how Subharti can contribute to achieve like well-being and good health. How best we can contribute in removing hunger. How best we can removing poverty. And through our commitment towards the society, how best we can contribute. But I'm sorry to say, like India did come in the 120th position in that. Reason is that message was conveyed, but implementation not done. It is not taken seriously. And even if it taken seriously, it's just taken as a tokenism. Do something, show it, take photograph and present, show it. But actual, today morning when I was going across in the morning walk, I found on the roadside that plastic scattered, plastic bottles are scattered here and there. And we have a Swachhta committee, we have a Swachhta, all these committees are there with us. We have been organizing various programs on 2nd October, and then we had so many other programs. But these programs should not become a symbolic or should not become a tokenism. Unfortunately, we believe in too much of a tokenism and we don't take things seriously. So my appeal to you all, please take environmental issue very seriously, take sustainable things very seriously, and it should start our own label, the personal label, individual label. Then it comes to family label, then it comes to village label, then it comes to mohalla label, or all like that. And then when really we work on, it will come to the country label, and that will come to the global label. So everything starts in your mind, at your personal label. If we find something is scattered on the road and we don't pick up and put it on the that area where it should be, it means we are failing our duty. We'll just ignore and go. I will give you an example. Today morning only, there was a one rat which was probably came under the one vehicle, and it was dead there, but nobody even tried to pick up that and throw it on somewhere it should be. Everybody was walking, checking and just walking. So this awareness and that kind of a responsibility we don't find. We must create this awareness, this kind of a thing in our mind. This country belongs to us, this place belongs to us, Subharti belongs to us. This atmosphere, this climate, this campus belongs to us. If we don't keep it clean, it will harm us, not to anybody. And moreover, if we take care of our environment today, if we take care of our earth today, we will be able to sustain it for long. And sustenance means our generation, future generation will be able to enjoy what we do today. Otherwise, we are not going to be on this earth for a long time the way we are exploiting the nature. So this conference particularly focusing on agriculture, how natural way of agriculture will be sustainable. We have got tremendous advancement in the technologies, but are these technologies will be able to sustain agriculture for long and will be able to sustain our life for long? That is the point we should think upon and deliberate upon. I'm sure all of us will benefit a lot from our learned speakers who will be speaking on this subject. I once again thank you very much and wish you all the best.
Thank you so much, sir, for always guiding and motivating all of us, including faculties and students, to do our best. We really feel lucky and blessed to have you with us. Thank you, sir. Thank you once again. Now, it's time to begin our technical session 1. Today, our first guest speaker is someone who has intrigued and mesmerized many of us through her lectures. It is an honor to welcome Dr. Dilfuza Jabarova, who is working as an associate professor in Institute of Genetics and Plant Experimental Biology, Academy of Sciences of Uzbekistan. She has gained her PhD in plant physiology and biochemistry from Plant Experimental Biology, Academy of Sciences of Uzbekistan. Her specialization and areas of interest are plant microbe interactions, biological control of plant disease, plant growth promoting rhizobacteria, some microbial ecology, plant physiology, plant nutrition. She has a vast research and teaching experience of above 21 years. She is also a research guide of various PhD scholars. She has participated in almost 8 research projects and also lead one of the projects on development and implementation of methods of cultivation and preparation of ginger and curcuma from 2019 to 2022. She has attended more than 5 training programs and workshops. She has acquired the following professional memberships: American Society of Microbiology, Society of Environmental Sustainability, Plant Biochemistry and Biotechnology, International Society of Environmental Botanists, the Association of Microbiologists of India. She is conferred with more than 4 fellowships. She got Global Scientist Award 2023 in Shimla, India, Global Recognition Award 2023 in India, Agra, International Scientist Award on Engineering, Science and Medicine in Hyderabad, India, Award for Excellence in PGPR Research 2019, Uzbekistan. And 3 more awards are also in her court and many more are sure to come. She has reviewed almost 18 manuscripts for various scientific journals. She is a member of editorial board of various journals like Frontiers in Microbiology, Annals of Phytomedicine, Plant Archives, Turkish Journal of Agriculture and Forestry. She has participated in 32 international conferences and also worked in some of the organizing committees of these conferences. She has published around 6 book chapters and 38 research papers on international reviewed journals. This is her brief introduction, as it is not possible to pen down all her achievements. So, ma'am, I kindly request you to please deliver your lecture. The dais and session is all yours, ma'am.
Good morning, professors, scientists, faculty members, and students. Firstly, I would like to my thankful to invite me Professor Amar Garg and organizing committee. Is it fine? Is it connection? Okay. Is it fine?
डिस्प्ले नहीं वायर सर्किट उनके लैपटॉप में ना ना चला था
Good morning, everyone. Today I am talking about my presentation title, Application of Rhizobacteria as Plant Growers, the Biological Control and Soil Health Improvement. Plant grower is a bacteria, very beneficial bacteria, and also production phytohormones such as asteaminase, gibberellin, stachynin, also improved in the plant growers, and also phosphate solubilizing, metal solubilization such as zinc solubilization, iron solubilization, and also nitrogen fixation in the by plant growth formation bacteria. Rhizosphere and plant growth formator is a bacteria. What is this is rhizosphere? Term rhizosphere given by Heltner and also term plant growth formation given Cloper. Rhizosphere in narrow zone of the soil, specifically influenced by the root system, also populated by microorganisms and the bacterial called rhizobacteria. Plant growth formation rhizobacteria including three types such as beneficial, deleterious, and also neutral groupers. Beneficial free living soil bacteria referred to as plant growth formation bacteria. Mostly plant growth formation bacteria such as Bacillus, Pseudomonas, also predominant bacteria in the plant growth formation rhizobacteria. Plant growth formation rhizobacteria and mechanisms including this direct mechanism, also indirect mechanism. What is direct mechanism? Providing plant with a compound synthesis by bacterium or facilitating uptake and nutrient from the environment. Indirect mechanism reducing of preventing deleterious effect of phytopathogenic organism by producing antagonistic substance or by inducing resistance. Plant growth formation rhizobacteria forms such as extracellular plant growth formation rhizobacteria and also intracellular plant growth formation rhizobacteria. In the includes Agrobacterium, Arthrobacterium, Azotobacter, Azospirillus, Bacillus, and Pseudomonas in the belongs to extracellular plant growth formation bacteria. Intracellular plant growth formation bacteria include this Alaryzobium, Bradyrhizobium, Mesorhizobium, and the Rhizobium. These insects specialize in the nodal structure of root cells. In the plant growth promotion, bacteria also mostly production in phytohormones, also nitrogen fixation, phosphorus solubilization. This one all direct mechanism. Indirect is also there's competition for nutrients, induced resistant, also antibiotics. Antibiotics. This is all is improving in the plant growers' physiological properties, also improved in the soil fertility. Mostly this nitrogen fixation two mechanism, such as symbiotic nitrogen mechanism and also non-symbiotic nitrogen fixation. For example, rhizobium, broad rhizobium, cinorhizobium, mesorhizobium, also this symbiotic nitrogen fixation. Mostly, broad rhizobium japonicum is a specific bacteria in the soybean plant. And this is many leguma plantas is specific bacteria such as mesorhizobium, cinorhizobium, and rhizobium, and for this mung-bean, chickpea, and cowpea. And non-symbiotic nitrogen fixation by leaving free the Astrophis, Acetobacter, Azospirillum, and the Astrophacus, and Pseudomonas also cyanobacteria. Effect of rhizobacteria on the plant growers. How can this is rhizobacteria improved in the plant growers? Because this is also relationship with rhizobia, also mycorrhizal fungi, also inhibition pathogenic microorganisms, also synthesis hydrolyzing enzyme agents, fungal cells, and also base control. Phosphorus solubilization. Mostly this Pseudomonas putida, Bacillus subtilis, Rhizobium bacteria also phosphorus solubilizing bacteria also improving in the plant growers, because plant doesn't take in the directly in the phosphor in the in the soil. There's mostly Arthrobacter, Bacillus, Pseudomonas, and Rhizobium phosphorus solubilizing, also helping to plant growers, also physiological properties. Also, these plant growth promotion rhizobacteria, such mostly also biocontrol properties of plant growth promotion rhizobacteria, and many of these phytopathogenic fungi such as Fusarium oxysporum, Fusarium culmorum, and Fusarium solana. What is biocontrol mechanism? In competition of nutrients, production of antibiotic, production of enzymes, degrade cell wall, production of siderophores, production of some metabolite, and also displating pathogens. In the Uzbekistan, mostly in the soil, also this is caused by Fusarium oxysporum. In the first time, we also isolated in the Mung-bean root Fusarium oxysporum rhizoctania solana. This is very harmful to plant growers, also many rhizobacteria also against to phytopathogenic fungi. Application of plant growth promotion and bioinoculant. This time is organic farming is very important in the world. Then how can using in the biofertilizer? Mostly biofertilizer is included in the Rhizobium, Arbusca mycorrhizal fungi, Acetobacter, and also plant growth promotion rhizobacteria, and prepare this biofertilizer. Then this is because this is very eco-friendly biofertilizer, and also improve in the plant growers, increase efficiency of nitrogen, ability in the phosphorus solubilizing, improve availability in zinc, also iron, and also Pseudomonas putida and Bacillus subtilis also improved in the plant growers, also biocontrol doing many phytopathogenic fungi. I also share my experience data, this biochar and mycorrhizal fungi for enhanced growers and physiological traits of soybean, okra, and soil properties under drought condition. What is soybean is very important, because soybean used in the main food industry, in the textile industry, chemical industry, engineering industry, in the medicine, also in the livestock. because in the used soybean in the food industry, such as confectionery industry, the bakery industry, industrial production of pasta, meat processing industry, and also used many days diet supplement in pharmaceuticals. Okra plant is also most important vegetable crop in the mostly rich also this antioxidant, vitamins, and also helping to for nutrients for human physiological properties. What is biochar? Biochar is very important organic biofertilizer. And also biochar nowadays in the trend, in the recent 10 years, in the more than this 3,000 paper is published in the Science Direct. Then also very important one, biochar journal impact factor more than this 12. Nowadays, in the many country also use it in the biochar for organic farming. Biochar is carbon-rich material that made from biomass raw thermochemical in the conversion process non-pyrolyzed. Mostly this biochar also pyrolyzed in the at temperature is this is 300 up in 1,000 grados. This is very beneficial for biochar production. This is 400 and 450 grados. Biochar plays an important role in improving soil quality, enhance also this soil fertility. Biochar, when you using in the soil, also improve it in the plant growers and physiological properties yield also this under stress conditions such as drought condition, also saline condition. And biochar also very beneficial, also decreasing in the global warming in the world, reducing atmospheric carbon concentration, in also helping to in the long time also keep in the soil humidity. What is Arbusca mycorrhizal fungi? Arbusca mycorrhizal fungi is very benefit in the soil microorganisms, also living in the this is plant symbiotic relationship, because more than this 80% plant also symbiotic relationship with Arbusca mycorrhizal fungi. Arbusca mycorrhizal fungi also plant this also improved in the plant growers, also improved in the soil quality, and also keeping in the plant growers, also physiological properties, and such as photosynthetic activity. Nowadays in the world is very big problem, also major problem in the drought stress. Many area is caused by drought. Drought also this decreases in the many crops yield and also physiological, such as Arbusca mycorrhizal fungi and biochar play important role in increasing plant growers, development in productivity plant. The objectives of this study to study the effect of biochar and MF on plant growth, to analyze the impact of biochar and MF physiological on microbial biomass and soil enzyme activities. In the biochar, this biochar also produced 400 and 500 grados and woodland biomass and legume plant. And soybean and okra seed was purchased at Division of Vegetable Science, and we Phenoliformis mostio, and our experiment used for treatment such as control without biochar and biochar alone, MF alone, and combination of biochar and MF used for seed of soybean cultivated in the plastic 40 days, plant also harvested. We analyzing in the plant growth plant growth parameters, physiological properties, also soil properties. The effect of biochar and MF on plant growth in soybean and okra under drought condition was investigated. When this inoculation biochar alone significantly increased in the plant height and root dry weight and also nodal number compared to control. A similar result showed that when this inoculation MF also improved in the plant height, root dry weight and also nodal number compared to control. When this used combination of biochar and MF significantly improved in the plant growth parameters such as plant height, root dry weight, and also nodal number compared to all treatment. When you use this similar treatment in the okra plant, when inoculation biochar alone improved in the plant height and also root dry weight. Similar results showed that when this alone treatment, MF alone, combination of biochar and MF, base result showed that in the improved in the plant growth parameters in okra plant. We also investigated the effect of biochar and MF on root morphological traits of soybean in okra under drought conditions. When this used in the biochar alone treatment, significantly increased root morphological traits such as total root length, project area, root surface area, root volume, and root diameter compared to control. Similar results showed that MF alone also improved root morphological traits. When this dual application of biochar and MF beneficial effect on the plant root morphological traits such as total root length, project area, and root surface area, root volume, and root diameter compared to control and other treatment. When this inoculation biochar alone to okra plant also improved root morphological traits such as total root length, project area, root surface area, total volume, and root diameter. MF alone also improved in the root morphological traits. When this inoculation, this combination of biochar and MF, mostly good result showed that improved in the okra plant is root morphological all traits. The effect of biochar and MF on chlorophyll content on soybean, okra, and the drought stress was investigated. When this biochar treatment used in the significantly improved chlorophyll content and the drought stress. When you use it in the MF, also this is improved chlorophyll content in the soybean and okra plant. This result showed that when this inoculation, when this used this combination of biochar and MF significantly improved chlorophyll content in soybean and okra plant. The MF sporus number in the soil affected by biochar and MF and the drought stress was investigated after soybean and okra plant harvested. Biochar treatment also improved in the MF alone sporus number, and MF alone also significantly enhanced in the MF sporus number. When this combination of biochar and MF, base result showed that it significantly increased in the MF sporus number compared to all treatment under drought stress. This is similar result showed that soybean also okra plant. We also investigated this microbial biomass. When this when this used biochar alone, MF alone treatment significantly improved in the microbial biomass in the soil. Biochar and MF together, this result showed that when this inoculation combination improved in the microbial biomass in the soil and the drought stress. The effect of biochar and MF on soil enzyme activities in the soil under drought condition was investigated. After soybean and okra plant harvested, we also analyzed in the soil enzyme activities. Biochar treatment also significantly increased alkaline phosphomonoesterase, dehydrogenase, and fluorescent acetate enzyme activity compared to control under drought stress. When this inoculation, this combination of biochar and MF most significantly improved in the soil enzyme activities, such as alkaline phosphomonoesterase and dehydrogenase and phytate enzyme activities. Similarly, results showed that when this harvested okra plant in the soil analyzed, biochar alone, MF alone also improved in the soil enzyme activities, also significantly enhanced in the soil enzyme activities such as alkaline phosphatase, dehydrogenase, and fluorescent acetate activity compared to control. Combination of biochar and MF most significantly enhanced alkaline phosphatase, dehydrogenase, and fluorescent acetate compared to control and all treatment under drought stress. My conclusion that when this inoculation, this biochar and mycorrhiza, arbusca mycorrhiza combination also improved in the soil enzyme activity, also enhanced in the plant growers such as okra and also soybean plant. Application of arbusca mycorrhizal fungi could be best symbiotic relationship with soybean plant and also improve MF alone promoted plant growers, root morphological traits, chlorophyll content, MF spores number, microbial biomass, improved also soil enzyme activities. Then this is in my conclusion that when this used dual application of biochar and MF can be used to decrease the effect of water stress, helping to improve soybean okra growth, yield, and improve in the soil enzyme activities, also soil nutrients. Then this my data already published high impact factor journal and frontiers in plant science. This is journal also Q1 impact factor more than 6. I am also sharing in the my data in the Uzbekistan his time we cultivated in the very important also this spice herbal plant. This is ginger plant. Ginger also very neat plant in India. Also use it every time for use tea or some spices product. And the screening plant growth promoting rhizobacteria for improving growers, physiological properties of ginger and soil properties was investigated. Ginger is spicy and medicinal plant belongs to Zingiberacea family. Ginger has long been used in the folk medicine India and China. It has been used in the folk medicine such as cold, sore throat, asthma, joint pain, and stimulate appetite. It is used to make gingerbread, sweet, ginger tea, cake, snack, and soft drinks in many countries. Ginger is also rich and beneficial in the nutrients such as phosphorus, potassium, calcium, which role in important human physiological properties. Rhizobacteria, I already mentioned, this is Rhizobacteria also very beneficial, eco-friendly, this biofertilizer used improved in the plant growers' physiological properties. The objectives of the study, to study the isolation of Rhizobacteria from ginger medicinal plant and identification by Maldatov, to determination of the Rhizobacteria on the plant growers, promoting traits such as salinity tolerant phosphosolubilation, protease and amylase, catalase, lipase, and osteoaminase production, to investigate the antifungal activity of Rhizobacteria against different pathogen fungi, to study screening plant growth promoting Rhizobacteria on the plant growers' physiological responses in the ginger. In our experiment, we use it in the ginger plant in the Uzbekistan first time in the cultivated in the Tashkent in Surkhandaryo region, and after we isolated this plant growth formation bacteria from ginger rhizome. Then after the selection in the best plant growth formation bacteria such as Bacillus subtilis, Bacillus pumilus, Bacillus altitudinus, Pseudomonas carensis, and Bacillus endophyticus, use it in the pot experiment. Ginger after 4 months, we also analyzing in the plant growth parameters, physiological and also soil properties. 19 bacteria isolated in the ginger rhizome after the identification in the mold top, mostly bacteria belongs to Bacillus subtilis, Bacillus pumilus, and Bacillus endophyticus, Pseudomonas carensis. This is similarly 100%. Then we also checking the salt tolerant of rhizobacteria. Then mostly these Pseudomonas carensis, Bacillus endophyticus, Bacillus subtilis, Bacillus pumilus also salt tolerant up 10% sodium chloride. Because in the Uzbekistan, there's mostly area also there's salinated. Plant growth formation properties of 19 bacteria was investigated, and mostly Bacillus subtilis, Bacillus pumilus, Bacillus endophyticus bacteria also. This is phosphosolubilizing in the promoting treatise. Also, this production as deaminase and also enzyme activities. And in the Uzbekistan soil also caused by many phytopathogenic fungi such as Fusarium oxysporum, Fusarium culmorum. After we also, these 19 bacteria, how can these affect to some pathogenic fungi such as Fusarium culmorum, Fusarium oxysporum, and Fusarium solana. Mostly these Bacillus subtilis, Bacillus endophyticus, and Bacillus pumilus also also these antagonistic activity and phytopathogenic fungi such as Fusarium oxysporum, Fusarium culmorum, and Fusarium solana. Effect of plant growth promoting bacteria on the plant growth of ginger was investigated. When this inoculation by Bacillus subtilis significantly increased in the ginger plant height, leaf number, leaf length, leaf width compared to control. Similarly, results showed that also Pseudomonas carensis improved in the plant growth parameters. When this inoculation, Bacillus endophyticus significantly enhanced plant height, leaf number, leaf length, leaf width compared to all treatment. We investigated that effect of plant growth formation bacteria on the total chlorophyll content of ginger was investigated. When this inoculation, Bacillus subtilis and also Pseudomonas carensis and Bacillus endophyticus significantly increased total chlorophyll content in the ginger plant compared to control. Bacillus pumilus and Bacillus altitudinus also improved in the compared to control total chlorophyll content and compared to control. We also investigated the effect of plant growth promoting bacteria on the carotenoid content of ginger plant. When this inoculation, plant growth promoting bacteria such as Bacillus subtilis and Pseudomonas carensis significantly increased in the carotenoid content of ginger plant. Similarly, results showed that when this inoculation, Bacillus pumilus and Bacillus altitudinus showed that similar results in the improved carotenoid content in the ginger plant. We also investigated related photic content in the ginger plant leaf. When this inoculation, this plant growth formation rhizobacteria, this result showed that Bacillus subtilis, Pseudomonas carensis, and Bacillus endophyticus mostly significantly increased related photic content in the ginger plant. We also investigate the soil enzyme activities as influenced by plant growth formation rhizobacteria. When this used biochar, when you use it, this Bacillus subtilis, Bacillus pumilus, Bacillus altitudinus, and Pseudomonas corensis also improve what this is soil enzyme activities. This is very best result showed that this is two bacteria in the Pseudomonas corensis and Bacillus endophyticus significantly enhanced catalase enzyme activity, invertase enzyme activity, urease and phosphatase enzyme activity in the soil compared to control. My conclusion that when this used in the plant growth formation, bacteria such as Bacillus subtilis, Pseudomonas corensis, Bacillus endophyticus significantly increased in the ginger plant growers such as plant height, leaf number, leaf length, leaf width compared to control. In the beneficial result showed that when this inoculation, Bacillus endophyticus significantly enhanced also physiological properties of ginger plant. Plant growth formation, rhizobacteria, Bacillus endophyticus significantly improved in the soil enzyme activities, and a positive effect of inoculation was more indicated Bacillus endophyticus, Bacillus subtilis, and Pseudomonas corensis. My conclusion that Bacillus subtilis, Pseudomonas corensis, and Bacillus endophyticus strains most effective option for environmental agricultural practice to promote plant growth and soil enzyme activities. Future research and development strategies. Plant growth formation is a bacteria very beneficial for plant, also soil, also this environment. Like this eco-friendly eco-friendly disease biofertilizer, because nowadays biotic factor also is increased, such as when this use of plant growth formation bacteria like biofertilizer also improved in the stress tolerant, growth promoting, yield enhancement, biocontrol, nutrient immobilization, and also eco-friendly. Because this plant growth formation is a bacteria also beneficial, arbusca mycorrhizal fungi also beneficial effect in the plant growers, also yield, also improved in the soil fertility. Also, this is very important for organic, this farming, also natural agriculture. Thank you very much for your attention. Do you have any question? Any student? Do you have any question?
Students, any question from anybody? Please clear your doubt.
My eyes cannot control because problem my eyes.
Okay, ma'am. Ma'am, you can stand over there. No issue is there. Hand nagging issue there. Okay. No question. Is there any question you want to ask? I don't think so, ma'am. No question is there. Thank you. Thank you so much, ma'am. First, for coming here from so far. And secondly, for enlightening us and giving insight into the topic of such importance, which actually demystify the theme details. Thank you once again, ma'am. Now, I would request our Dean Ma'am, Dr. Renu Mavi Ma'am, to present the Certificate of Honor to Dr. Dilfuza Jabarova Ma'am. Ma'am, please. And all organizing chairpersons, please come on the stage to present the Certificate of Honor. Amit sir, Sangeeta ma'am, please. A big round of applause, students. Thank you, ma'am. Thank you, sir. Now, it is my proud privilege and honor to welcome our next esteemed international speaker for today's event, Dr. Binay Kumar Chakrabarti, who is joining us in online mode. We are waiting him to join.
Yes, yes, in laptop. Yes. Yes. I am in laptop.
Welcome. Welcome to this International Symposium on Natural Agriculture for the Sustainable World. So let me introduce and tell about the achievements of Dr. Binay Kumar Chakrabarti. Dr. Binay Kumar Chakrabarti is a professor and project director in Department of Fisheries, Bangladesh. He is a fisheries scientist and consultant and has played an important key role as a researcher and extension worker in the field of aquaculture and fisheries management of Bangladesh, especially in the coastal aquaculture field of mud crab and mud eel, shrimp and sea bass, coastal fisheries livelihood, climate resilient sustainable management and conservation of wetland resources and biodiversity of wetlands. He is a supervisor, co-supervisor of Bangladesh Agricultural University, who has guided so many students and worked as an examiner of PhD student abroad. in culture of Cusia and crab in the selected areas of Bangladesh and research project, he has discovered and development the technologies on mud crab juvenile culture, crab fattening of pen culture, cage culture of crab, survey on stock assessments of mud crab within Bangladesh, established a crab hatchery in Cox's Bazar and experience on hatchery management, fisheries livelihood development. He has discovered control natural breeding of eel, nursery and culture management of eel. In CREL project, he directly participated in climate resilient, sustainable management and conservation of wetland resources and biodiversity in selected wetlands and strengthening planning and implementation capacity of co-management bodies in high biodiversity and highly climate vulnerable areas. The result was viable livelihoods and enterprises that increases incomes, sustain resources and productivity and highly climate vulnerable areas. The result was viable livelihoods and enterprises that increases incomes, sustain resources and productivity and improve resiliency, especially among marginal and vulnerable populations. In Fisheries Diploma Course Implementation Project, he has firstly successfully established the mid-level fisheries manpower Fisheries Diploma Institution in Chandpur, Bangladesh, and introduced course curriculum with Bangladesh Technical Education Board under the project Fisheries Diploma Course Implementation Project. He has an expertise on breeding, nursery, and culture of major carp and minor carp, and catfishes. Expertise on crabs, Macrobrachium, Rosenbergi, and Pinus mondon culture, and other coastal and sea fisheries management. Sir has been acting as a reviewer more than 23 different international journals. He is also editorial board member of International Journal of Oceanography and Aquaculture, Asian Biological Research Foundation, and International Journal of Advanced Academic Study. He is also a life member of the 15 national and international societies organizations, about 15 research and academic books, 7 book chapters, more than 70 abstracts, and 72 scientific papers and other 38 articles are published by national and international publishers and organizations. He has attended more than 92 international national seminars of different countries of Europe, Middle East, Southeast Asia, and our own country. So, Sir is requested to begin his session, if possible, if he is connected. So, please, can we have presentation and your just
I think you have to help me to share the screen. I am not possible to share from here. I am trying, but not possible. What is happening?
to begin his session, if possible, if he is connected. So please, can we have presentation and your just
I think you have to help me to share the screen. I am not possible to share from here.
Okay, sir. Okay, sir.
I am trying, but not possible.
Sir, we are doing it, sir. We are doing it for you, sir. Sir, start. Sir, you may start, sir. We are sharing your slides, sir.
Whose witness session, if possible, witness selected. So please kindly have presentation and your
I will help me to share the screen. I am not possible to share on the.
Do you hear me? Do you hear me? Hello? Hello?
Sir, we are doing it, sir. We are doing it for you, sir.
Okay, I want to continue, please. Hello? 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 Oh, Shala.
Sir, start. Sir, you may start, sir. We are sharing your slides, sir.
Can I continue my lecture? Hello? Hello? Hello?
whose witness session, if possible, witness selected. So please kindly have presentation and your
Do you hear me? Do you hear me?
Yes, sir, you are very much audible, sir.
Hello?
Yes, sir, we can hear you.
We are doing it, sir. We are doing it for you, sir.
Okay, I want to continue,
Sir.
please.
Yes, sir. Yes, sir.
Hello?
Sir, you may continue, sir.
Okay.
Yes,
I'll
sir.
continue. Yes, sir.
Start.
Okay.
So you may start, sir. We are sharing your slides, sir.
Today's my presentation is on very important topics. It is aquaculture and sustainable development.
Yes, sir. You may continue, sir. You may start your lecture, sir.
Yes, sir. Yes, madam. Actually, it's a very important issue. Not only in Bangladesh, in all over the world, aquaculture sector is very important. We know that there are 17 sustainable development goals aims to achieve decent life for all on a health plan by 2030. But what is happened in case of fisheries and aquaculture sectors? It is
Yes, sir, you
linked
are very
with
much audible, sir.
LTG
Yes, sir, we can
1,
hear
2,
you.
3, 5, 6, 8, 9, 13, and 14. And LDG rank in Bangladesh 104 of 136,
Yes,
and
sir.
score is
Sir, you may continue, sir.
4.22,
Yes, sir.
is ranked in the last year 2022. And I want to now say what's the contribution of this sector. Fisheries and aquatic resources
Yes,
provide a
sir.
rural
You may continue, sir. You may start your lecture, sir.
profit and save money. Fish consists is very important issue. 15 to 24% protein, 1 to 3% carbohydrate, 0.1% lipid, 0.8 to 2% inorganic substance, and 66 84% water, and provides calories, nutrients, that is fat, vitamin, elements like this. Fish contains the best protein than that of meat and poultry. And the doctor's advice to the patient to take fish to take fish because of highly nutrients and good water, good feed quality. Fish production of Bangladesh was last year 4.76 million metric ton, and fisheries sector contribute 2.08% national GDP, and 21.83% agricultural GDP, 1.05% to the export earning. This is the achievement. And what is the happening? About 12% people of the total population lead their livelihood directly or indirectly on fisheries sector. Fish alone supply a per capita fish consumption of that is 62.58 gram per day in daily dietary requirement. What is the methodology? Methodology is the method is followed. Develop a semi-structured questionnaires. Collect primary data by focus group discussion, local ecological knowledge, direct interview with the individual respondent, that is fisherman, farmer, transporter, piker, arodhar, social worker, and other stakeholders. Sir, sir. Okay, sir. Okay, sir. Okay, I am continuing. Okay. Okay, okay. I want to stop now. Okay, sir.
Thank you, Ekta ma'am. Before beginning of the second technical session of the symposium, I, Dr. Supriya Tomar, welcome all the dignitaries, deans, faculty members, and students on behalf of Keral, Verma, Subharti College of Science. Now, it is time for brief introduction of our Dean Academics, Dr. Amar Prakash Garg, who is our next resource person. Dr. Amar Prakash Garg is taught first class MSc, PhD, LLB with 48 years of teaching and research experience in microbiology, biotechnology, and environmental sciences. Presently, Sir is Dean Academics and Director Research at our Swami Vivekanand Subharti University, Meerut. Formerly, Sir was Professor and Founder Head at CCS University, Meerut. Pro-Vice Chancellor at JNU Jaipur, Vice Chancellor at Shobit University, Meerut. Sir is recipient of Young Scientist Gold Medal of the Indian Botanical Society and Professor Hiralal Chakravarti Award of the Indian Science Congress and Association. Sir has been announced as Best Paper Presenter at Germany. Sir has published more than 185 research papers. Sir has supervised 50 PhD and 75 MPhil and more than 100 research projects of PG students. Sir has been one of the Commonwealth academic staff at the University of Ashton in Birmingham, 1982 to 83, University of Liverpool in UK, 1993 to 94. Sir has also worked as Dart Fellow, University of Freiburg and University of Heidelberg, Germany. Sir has participated in more than 24 of international conferences abroad, chaired various sessions. Sir has been engaged as academic advisor to International Union of Microbiological Societies, IUMS Congress 1994. Sir has received grants from Royal Society London, UNESCO, Japan Research Council, British Council, DART, DFG, Germany, and other national and international organizations. Now, sir, dice and session is all yours.
Thank you very much. My pleasure and honor to be in this one-day international symposium at Subharti. So, without wasting much time, I will come directly on the topic what we have decided, that is the natural agriculture and sustainable world. As the Honorable Vice Chancellor, Professor Tapalyal, he told you that the Sustainable Development Goals, which were launched by UN in 2015, but if you see, then these goals were first developed in 2003 itself. In 2003, the world community, they decided that the entire earth is not worth for living the people. And they thought that we should work together to make such a world which can sustain the life for longer time. You all, I think, that are the students of biology. And you know that our genome is made up for 120 to 150 years. And if we are living for less than that, it means something is wrong. And where it is wrong, it may be wrong either in your lifestyle or in the environment or in the food habits or something else, something is wrong. And you know that the highest life rate in the world is only 82 in Japan. And India, it is only about 70 to 72. And if you see the Vedic period, go long back to the thousands of years, you will find that the Rishi Muni who used to live in Himalayas, they used to live for 300, 400 years. What was the reason for that? The oxidation, most of you know the oxidation process is the one of the thing which reduce your life. That is the oxidation of your genetic material, oxidation of the genetic material of mitochondria, oxidation of the nucleic acids, and this is the main problem. Now, if you go to the hills, if you remain over there, then at that place the amount of the oxygen is less. The rate of the oxidation is reduced. That is the one thing. And the second thing, that the rate of the oxidation you can reduce by using antioxidants, by changing your food habits, by changing your lifestyle, and by stopping the pollutants in the environment. By drinking the good clean water, by taking the good clean air, you can reduce the oxidation. That is the entire concept of the sustainable world. Now we come that what agriculture, because agriculture, you know that this is one of the system which provide you the food. Not only the food, but even the shelter, even the clothes, even the everything it provides you. And for that, I have decided this topic, that is the natural agriculture for sustainable world. Now, if you see that these are the 4 different parameters around which the entire world revolves. If we see that the reliance on the solar energy, that is the only source of energy which provide you every type of the energy, whether it is chemical energy, food energy, nuclear energy, fuel energy, any type of the energy. This is the only source in the universe. Only the form of the source, only the form of the energy, what you use, it keep on changing. Whatever the amount of the radiation comes from the sun, only 1% of this radiation comes on the earth. And out of this 1%, only 0.1% is photosynthesized. And this 0.1%, you can see that this is giving you the entire life. The photosynthesis is the process which converts the solar energy into the chemical energy, and the rest of the chemicals, they are produced after that due to the metabolism. You all are the students of biology and you understand. So I'm not focusing on that. So that is the one thing, that if we focus and concentrate on the solar energy, then we can prepare and we can make this world sustainable. The second important thing is the biodiversity. Biodiversity, why biodiversity? Because every life form in the universe is having the different role. Every student who is sitting over in this beautiful hall, you all are having the different roles. If you see the entire university as a universe, you will find that the vice chancellor has different role, registrar has different role, finance officer different role, dean different role, even the sweeper has the different role. And any of the person, if derailed, then the entire system will be derailed. So the biodiversity is one of the most important aspects which need to be focused, which need to be conserved, which need to be maintained. And for that, the sustainability is important. The third important thing is the nutrient cycling. Whatever the nutrients you get in the entire universe, they need to be recycled. If they are not recycled, then you will find that nothing will happen. Only the photosynthetic part, the synthetic part we know, but we do not know the other part, which is, that is the decomposition, degradation, recycling of the matter, recycling of the nutrients, recycling of the trace elements, recycling of the carbon, nitrogen, hydrogen, water, everything. This is very important aspect. And the fourth important aspect is the population. I will come later on. So my entire lecture, it will revolve around all these four parts. Now this is the one of the slide which I was talking day before yesterday on Nalanda University platform. And I spoke on this slide for 1 hour. But I will reduce, this is the one of the major slide or the most important slide where I would like to invite your attention. And you will find many times you see that most of the people, they say grow more plant, more plant, more plants. Forestation, forestation, forestation. I'm not against the forestation. I'm not against the plantation. But you have to think. You have to decide that what we need. What we need, because now this is the research of the 2022, just last year. In 159 countries, the scientists from 159 countries, they collected the data and they have, this is the combination of the several research papers. Now, what is that you will find over here, that the entire biomass, do we have the mic? This biomass, in terms of the carbon, you are seeing the first figure 548 point. You see here. Here this 545.8 gigatons, this green biomass. Now this green biomass, it present on this earth. Now how much you want? And this green biomass, it is constituting 82.4%. So do you want that all the green plants, they should be 90%, 95%, or how much you want? Do you want to further increase? I'm talking of in terms of the entire universe, entire earth. Now the 82.4% is already the green biomass. And if you will continue to increase it, this percentage, then what will happen to the other life forms? The other life forms will be reduced. And now you see that this is the part which I am focusing here. This is about 16%. This 16% part is mainly responsible for degradation, for recycling of the nutrients, for decomposition, you can say. And in nature, we call them as the natural scavengers. You just think that if on one day the sweepers doesn't come to your university, what will happen? Just you think. The entire university will not function. So if these natural scavengers who are cleaning the nature, who are cleaning the dump, if they are disturbed, if their population is disturbed, then what will happen, you can think of it. When you go to Delhi, you find on the left hand, there is a huge dump of the waste. And this huge dump of the waste, what it gives you the idea. And if it is not decomposed, if the microbes are eliminated from the earth as a whole, then you can think that what you will find, everywhere you will find the dump. Everywhere you will find the dump. So for the sustainable world, we need not to focus just on the plants. We need not to focus just on the animals, but we need to focus on each and every life form of this universe. And for that, the microbes, they are also very important. Bacteria, fungi, archaeobacteria, viruses, protists, everything. They are very important. Now I come on the another part, that is, you see that the 4.47% is the animal. This is the carbon, in terms of the carbon biomass on this entire earth, 0.47%. And the entire earth, if you see, you will find that the 70% of the earth is occupied by the human, and 30% earth we have left to the animals. And how much is the population of the, in terms of the biomass of the human? Only 0.01%. This is most surprising. Many of you might not be knowing it, that you are constituting only 0.01%. And this 0.01% is the problem of the entire earth. Just you think, are we contributing anything for the sustainability of the earth? We are taking oxygen, giving out the carbon dioxide. Are we contributing anything? We are living in this hall, for example, the air-conditioned hall. We are eliminating the gases which are injurious to the environment. Whatever we are eating, whatever we are doing, whatever the comfort we are increasing in our life, every comfort, everything, we are using the computer, we are giving this electronic waste. We are using the mobiles, we are giving this electronic waste. We are using the television. So whatever the thing we are using, that everything is disturbing this nature. And you know that Government of India in the month of, on 1st April 2023 has introduced a legislation. I do not know that how many of you know that every industry is supposed to recycle 60% of the product what they have brought in the market. That is the life of the every product, electronic product, or those which are having this electronic waste or the plastic waste or the polythenes, life has been decided. For example, the life of the television, it has been decided that 10 years, refrigerator 9 years, mobile phones 3 years, and all these things. After that, the company can buy back and the company can recycle it. So the recycling is one of the most important, because it is very difficult to recycle this electronic waste. And so that is why the Government of India, this is also a part of the Sustainable Development Goals that has been brought the policy. So if you see the entire thing, then you will find that the problem is not the green biomass. What I want to emphasize over here in this hall, I was the sectional president of the Environmental Science of the Indian Science Congress, which is the largest and biggest body of the Science Congress of India. And I also emphasized at that place that green biomass is not the problem. The problem is the dumping of the waste. Problem is the plastic. Problem is the polythene. Problem is the electronic waste. And these problems need to be addressed, need to be solved for the sustainable world. Now this is the population you will find, and what is expected, what is projected, that by 2050 the population is projected to be 10 billion. And at present the population is 7.8 billion of the entire world. And you know that every fifth person in the world is Indian. Our population is 1.42 billion already. Now, to feed this population of the 10 billion by 2050, what we need the changes in the agriculture. And what we need, the most important thing are the 3 points. What I have summarized, this 56% of the food gap between the crop calories produced in 2010 and 2050. That is, by 2050, when we will be having the 10 billion of the population, the 56% of the food will be required more what we needed in 2010. And to increase this 56% of the food, at the same time, the land will be reduced. Land will be reduced, the requirement of the food will increase. So where lies the solution? Do we want to die hunger? No. So the solution lies in the agriculture. And for that, what we need, 593 million hectare of the land gap to produce this 56% of the extra food. And the gigatons, 11 gigatons of the greenhouse gas mitigation will be produced. When we will increase the production, when we will increase this 56% of the food, then the greenhouse gas. So the problems are multifold, and these multifold problems need to be addressed right now if we want to survive for a longer period. So what are the solutions? The first solution, what I suggest, that first thing is reduce growth in demand for food and other agriculture products. Reduce demand, that it don't waste. America alone wastes 40% of the food. India is also wasting 15% of the food. India is also wasting 20% of the food in the storage. If you see, in the last year, before last year, Supreme Court directed the government of India to distribute these grains and the food free of cost to the poor. This is not a political agenda. This is the directive of the Supreme Court, because a lot of the food material, it was being wasted. They could not store. And a lot of food grains, it was spoiled during the storage. So the Supreme Court decided and directed the government that you distribute it to the poor people. So these things are the solutions where we need to address, where we need to think. And I'm happy that now the government of India, during the last 6, 7 years, 10 years, the government of India has started in focusing on these sustainable development goals and on these good practices for the welfare of the people. The avoid competition of the bioenergy. This is also one of the things which I want to focus. The many of the things now people are saying, and the government is also saying, and the sustainable world and the entire scientific community also is saying that bioenergy, green energy. Okay, fine. But don't compete it with the food crops. You will have to make a balance. The balance is very important in the entire universe. And whenever this balance goes out, then everything is out. If you eat more food, you are having the obesity. If you drink more water, you will be having the problems. If you will eat more tablets, you will have problems. So everything balance. Just you think that whatever is required for your body, that is the same is required for the nature. Just you compare. The philosophy of both is the same. Nature is also a human body. achieve replacement of the level fertility rates. This is the one important thing which I want to focus, that the 10 billion of the population. I was talking to some of my colleagues last time, and this is a very controversial and debatable point, that how much population the earth can sustain. Some scientists are of the view that the earth can sustain 10 billion of the population. Some scientists are of the view that the earth can sustain the maximum population of the 1 billion. And we are already at 7.8 billion. Now what we are doing, that to increase, with the increasing of the population, we are weakening the earth and increasing the load on the earth. The recent example you have seen in Shimla. The another example you have seen in Joshimath. What we did there, we increased the load on the earth. And now everything is, so these are the few examples which I am telling you that we need the sustainability, we need the sustainable world, and for that we need the balance. Balance in population, balance in everything. एक कहावत है कि ज्यादा अच्छाई भी बुरी होती है. अगर आप बहुत ज्यादा अच्छे हैं तब वो भी बुरी है, और आप बुरे हैं, बहुत ज्यादा बुरे हैं तो भी बुरे हैं. So make a balance in your life. If you are studying 20 hours, this is also bad. If you are not studying even for 2 hours, this is also bad. So make a balance in your life. Now the second point, solution what I have suggested, that increase the food production without expanding agricultural land. How we can do it? We can do it by using the modern smart technology. We can use biotechnology. We can use smart agriculture. We can use microbial foods. We can use green economy. And we can use several other new techniques to increase the food production without increasing the land. For example, this is the size of this room you are seeing. If I want to produce the single cell protein using the microbes, I can produce that much amount of the single cell protein in this room, which will be enough for 1 week feed of the entire Meerut, 35 lakh people, 3.5 million people. That is, so by 2050, what will happen? That the agriculture will be replaced by the microbial foods, and already the biotechnological populations, biotechnological industries, they will start. You know that even now these technology are famous. These technology are known. In space, the people are going. Do you think that they are carrying the food with them? No. They are carrying the tablets. They are carrying the microbial foods. They are carrying the energy. So this will happen, that it will become popular by 2050 for every person. And so the biotechnology and microbiology are the science which will be required for the coming generations. And that is why this is one of the things. Increase the livestock production. Livestock production we have to increase, improve the crop breeding. As you know that the agriculture people, they are making every day the new varieties. And if you see 1965, we were importing the food grains. And you might be knowing that the generator of the Green Revolution, Professor M.S. Swaminathan, he expired just last week. And I met him in 1975. And then when I was in Jaipur, then also he died at the age of 98. And so the plant breeding is one of the very important aspects which can produce you the high yielding varieties, early maturing varieties, and the high nutrient varieties. So that we have to focus. Many of the students, you are from the agriculture in this hall. So you should learn the techniques of the plant breeding, so that you can make the new varieties. Then improve soil and water management. This is one of the very important aspects. As you know that the quality of the soil, fertility of the soil, it is going down day by day. When I used to do the research in 1975, in Meerut, the carbon of the Meerut soil, it was 2.5. But now the carbon of the Meerut soil is only 0.3. Nitrogen is not the problem. The problem is the carbon of the soil. The carbon profile of the entire soils of the India, it has been done. And now the scientists, they have focused, and they are focused, as Dr. Jabaruba was telling in a lecture, promoting plant growth promoting bacteria. Not only they increase the nitrogen supply, but they also increase the carbon profile of the soils. So such type of the technologies we need to focus. The plant existing cropland and more frequently, and adapt to climate change. This is another very important point which all you should know, that the climate change, as you know that now the temperature is rising even in this month of October. During the day period, the temperature is 35, 36, 37. But before 50 years, in October, the temperature used to be around 25, 26, 27. So this change in the climate, and due to the change in the climate, you are finding the floods. So we have to develop that climate resilient agricultural technology, and that is why you know that the government of India has already started focusing on the millets crop, the bajra, jowar. These are the such of the crops which can be cultivated under the climate resilient technology. And the 2023 year, it has been designated as the International Millet Year. That is not only in India, but this is the focus of the entire world. This is the focus of the UN Sustainable Goals, that we should focus on the climate resilient technology, that is the millets. Protect and restore the natural ecosystem and limit the agriculture land shifting. That is the one very important thing. That is, we should stop using the agriculture and constructing the industries. I would like to give one example of the Rajasthan. Rajasthan is having a law that if you want to build the industry, if you want to build the institution, if you want to build anything, then you have to use that land which is not producing the agriculture crops, barren land. They have stopped that you are not allowed to use the productivity land. That type of the law is required to be made in the entire country. The entire country should focus on that. Link productivity with the gains and the production of the natural ecosystem. Link inevitable cropland expansion to the lands with the low environmental opportunity, and conserve. The last point, very important point, is this: the conserve and restore peatland. Peatlands. This is one of the very important. This is a part of the forest ecosystem which should be conserved, where the peatland, because this is very important. It is the 2% of the world greenhouse gases. Next, as Dr. Vinay Chakravarti will speak, because he is a scientist from Bangladesh, director, and he has been working on the fisheries since more than 45 years. So that we have to increase the fish supply. How many of you consider that the fish is the non-veg? Can you raise their hands? How many of you consider that fish is non-veg? No one. You all consider that this is the veg. It is veg or non-veg? Non-veg. Fish is non-veg? No. Sometime we will discuss. Sometime, because this is a very long lecture. So I will discuss that. zoology pupil will not agree, Sangeeta will not agree with me. Or Nisha, I think she is not here, she will not agree with, but I will convince them. Veg. Even the animals. Finally, if you will, finally, in the entire ecosystem, you will find, in the entire ecosystem, everyone is eating the plants. And they are being metabolized in one or the other way. So what is veg, what is non-veg? As a microbiologist, I'm not convinced. As a scientist. But as far as the religion is concerned, that is a different issue. But as a scientist, there is no difference in the physiology, in the biochemistry, in the biochemical composition, and in all the element composition, there is no difference. So we will discuss sometime when we will get time. So increase the fish supply, and if you increase the fish supply, then also the food required, because the marine, you know, the 80% of the productive, 80% of the space is occupied by the marine, and the marine biology or the marine productivity we are not consuming. We are depending just on the terrestrial economy, on the terrestrial system. But if we start focusing on the marine economy, marine productivity, then everything will be solved. The problem will be solved. We will have the surplus food. The nature has given us everything in surplus. But the only thing is that we are not focusing, we are not utilizing it in a right way. So I think that I will not focus much. Dr. Vinay Chakravarti, he is hearing me, and I think that I request him to focus in his lecture and convince these people that the fish is the vegetarian. Improve productivity and environmental performance of the aquaculture. Then the fifth point is reduce greenhouse gas emission. This is one of the most, the carbon emission. You know that carbon is the most important pollutant, and you have to reduce it. And if you are not reducing it, you will be reduced. You will be reduced. So the choice is yours. Either you reduce carbon or you reduce your life. Now these are the 17 sustainable goals. I am coming on that, which were decided long back, and Professor Sri Prasad Vishta, he is the member of the UN Committee for the Sustainable Development Goals. Why I am telling you that, why we selected these people in this seminar or in this symposium, and you will hear him, and he is one of the brilliant scientists who has for the first time mapped the soil of the world. He has developed a system which is having the mapping of the soils of the entire world. So you will hear him and you will listen him, and he is a person who is a member of this Sustainable Development Goals Committee from Nepal. So these are the 17 sustainable goals which have been decided by the international community, the UN, and we all have promised to achieve these goals by 2030. Now, what is my opinion as a scientist? Where the India needs to focus, because all these sustainable development goals, 17 sustainable goals for the entire world, but it doesn't mean that every country needs to focus equally on all the 17. India needs to focus mainly on these 10. No poverty. We have to focus on the poverty, zero hunger, good health, quality education, as Professor Thapalial was talking in the morning. And this is the mandate of Subharti University, quality education. And we are committed for that, and we will provide you the quality education, and we will focus on that. Clean water and sanitation. affordable and clean energy, industrial innovation and infrastructure, decent work and economic growth, climate action, and the life on land. These 10 sustainable goals I have proposed, and I have submitted this proposal to the government also, that we should focus on these in the first priority, so that we can achieve a target. We are at the 120th position. So if we focus on these, for example, this poverty, no poverty, these three goals, these are the one important things where if we focus, then we will be able to raise the status and the index of India in the sustainable development goals. These are the, again, 6 major points what we focus on, which the India should focus. That is the digital revolution. This is also related to the sustainable development, human capacity, demography and health, consumption and food, decarbonization and energy, and the food, biosphere, and smart cities and mobility. These are the 6 major points which we should focus as an Indian or for the Indian growth. Now 7.8 billion population of the world. And you will wonder to know that only less than 1/3 population is well fed. Less than 1/3. And rest of the world, they are either undernourished or are having the less food to eat. Less food to eat, it also includes that they are not getting the quality of the food. They're not getting the quality of the food. In India also, more than 50% of the people, they are not getting the quality of the food. And this is not just that everybody should have the food to fill his or her stomach. But the thing is that the person should have the quality food, the nutrients, balanced nutrient for the balanced growth. And on that, the agriculture needs to be focused. Now, the biofertilizer and natural, as Dr. Jabaroba Dilfuja in her lecture has already touched, so I will not focus on that. I think that my time is also running out, so I will go now fast. How much is time left? So some of the biofertilizers which are commercialized in India and they are available, and many of the farmers, they are using them. So we can't say that the India is behind the natural agriculture. The natural agriculture is being focused, and many of the biofertilizers which are commercially available, they are even in Meerut, there is the Dayal fertilizers, and we are also doing, and maybe that biotechnology students, one day I will come to your lab and I will show you that how we can very easily we can isolate the biofertilizers from the soil and we can use them. So sometimes I will start, because presently I am focusing on the research, and then maybe that after a month or so I will start interacting with the biotechnology, microbiology students, and at least once a week I will come to your lab, particularly for the practicals. So the cyanobacteria is one of the aspects, as you all know, that they can be used as the biofertilizers, several of the cyanobacteria. There's algae, several algae, they can also be used, and they are commercialized. Comparison with the other countries, if we see, then still India is using less biofertilizers. If you go to Japan, if you go to America, if you go to Mexico, if you go to Canada, if you go to Germany, if you go to England, if you go to other countries, you will find that they are using. But at the same time, now what is the beauty of the India? The India is using everything balanced. Now you know that what was the fate of Sri Lanka? Sri Lanka, they started the natural agriculture and they said the entire country will use the natural agriculture. They stopped using the chemicals completely. And what happened? Their productivity fell down. Their productivity fell down, and it was only 40% of the last years. And what happened? You know, so in India, only 2% of the farmers are at present using the natural agriculture. But I don't mean to say that the people should not focus. People should focus. The natural agriculture alone cannot solve the entire problem. We will have to use some sort of fertilizers. We will have to use some sort of chemical fertilizers. We will have to use some sort of pesticides. But the only thing what we need, that we need to stop the use of the systemic antimicrobials. Because the systemic antimicrobials are more harmful and they are the dangerous, not only for the microbes, but when they go into the food chain, then they cause the carcinogenic compounds in your food also. So we need to focus and we need to make a balance. And on that, our agriculture ministry, they are focusing. IARI and several agricultural universities, they are focusing, they are producing the new technologies which are sustainable and which are utilizable for the countries. Biopesticides, that is instead of the insecticide or the chemical insecticides, chemical fungicides, chemical bactericides, we can use the biopesticides. They are also easily, they can be produced, they can be identified, they can be cultivated, they can be manufactured, and they can be easily and without any health hazards they can be used. This is our own work, that what we isolated this trichoderma, a fungicide which is a biocontrol agent, and this is the slide of and this can be used as one of the biocontrol agents as a biopesticide. The commercial biopesticides, they are available in India and you can find them easily, you can purchase them from the market. Green economy, that is the agriculture. How much time is left, Sangeeta? Yes, I'm going to finish now because I have another lecture today. Lecture is the orientation. So the green economy is the another thing where we need to focus. Green economy, that is the food and beverage. Have you checked with the Dr. Vinay Chakrabarti? Trial करवा लिया उनका, करवा लिया. डॉक्टर विनय चक्रवर्ती का ट्रायल करा लीजिए. So food and beverages that we can produce through the agriculture. Green economy, that is a green economy. The food and beverages, industrial fermentation, fermented food, it will be the biggest industry by 2050. Fermented food. Everything you will find in the market, the fermented foods, because fermented foods without any chemical preservatives. If you are using the biopreservatives, so the biopreservative, this is now the new concept. And just last year we published few papers on the biopreservatives, that is the Indian spices. They can be used as the biopreservatives. Because you know that the salt and the chemicals, what generally they are being used as the preservatives, they all are injurious to the health. Even the salt, the higher concentration of the salt, they increase your blood pressure. They enhance your blood pressure. So that is why now most of the health conscious people, they are of the opinion that the salt should also be very less or no salt in the processed food. So the processed food should be avoided, but the Subharti University will focus on that. That is how the Indian spices can be used as a biopreservative and which will add the flavor to the food also. And we will be working now, continue to work on that, how this can happen. Enzyme technology is the another aspect where we need to focus in the green agriculture. And you will find that you all students of biology, so you know that many of the enzymes, cellulases, gyllinases, ligninases, manganese peroxidases, oxidases, oxidoreductases, hydrolases, several lipases, several types of the enzymes, they are being used by you in the present day. Many of the products which you are buying from the industries. And now these need to be focused more and more How many of you have used the biological system for controlling the disease? आपके पेट में कभी गड़बड़ हो गई तो आप में से कितने लोगों ने प्रोबायोटिक यूज किया है? Can you raise the hands? Yes. Enzymes, Unigyme. So several type of the enzymes now they will be in the market and they will control your system. In the next 30 years, you will find that the medical treatment system will also be changed. Instead of the chemicals, instead of the chemical drugs, the people will start using the biotechnological products, agricultural products, natural products. And during COVID-19 pandemic, the people have learnt the importance of immunity. The people have learnt the importance of vegetarian food. The people have learnt the importance of the quality nutrition. The people have learnt the health, good health, and that can be maintained. And for that, we have to focus on the agriculture. Metabolites from microorganisms, nutrition and drugs, which I am talking with you that everything, the supplements of the vitamins, supplement of the enzymes, supplement of the trace elements, supplement of the nutrients, they all are from the microbes, which you get the health foods in the market. These health foods, if you see, then you will find that there is some biotechnological process which is responsible for their production. So in biotechnology, students, I would like to invite your attention that in biotechnology, you should mainly focus on that the production, on the productivity, on quality testing. There is lot of scope. But the only thing, the scope is for those who are having the quality education, who are having the quality of the practical knowledge. Quality of the practical knowledge. Only for them there is a scope. But if you are not having the practical knowledge, then I'm sorry, then there are less chance of your employment. But if you are having a practical knowledge, if you are having a good practical hand, good system, good things, then you will be able to compete in the world. Bacterial polysaccharides, polyester, everything you will find that every organic, inorganic molecule, they are being produced by the microbes. Green economy, agriculture production, this is continued. There's a biological fuel generation, single cell protein and biofuel, you know. Now the government of India has also introduced that from April 1st, 2023, the 20% of the ethanol is being mixed in this fossil fuel, in the petrol and petroleum. And the target is that by 2030, we should be able to completely replace this petrol with the ethanol, bioethanol. Brazil is a country which is using the highest amount of the bioethanol and the biofuel. So it will not only save the foreign exchange, but it will also save the environment, sustainable development. So we have to focus, and we are living in the sugar belt in Meerut region, the northern region of this Uttar Pradesh, where this sugar belt. So we will be having the much bigger advantage that the sugar cane will be able to produce the ethanol, and that ethanol will be able to be mixed with the fuel, and then it will. So the environmental biotechnology is another very important aspect. And as I discussed you in my third slide, that every type of the molecule, biomolecule, compound which is present in the earth or on the earth, it is degraded by the microbes. Even the plastic, polythene, these are also degraded by the microbes. But the process of the degradation is slow, and dumping of these waste is more by you. That is why there is surplus of these waste on this earth. So we have to make a balance. And that is the environmental microbiology, where we need to focus. Agriculture, biotechnology, soil health, soil fertility, microbial diversity, microbial insecticide, biofertilizer, plant cloning techniques, as Dr. Jabarova discussed. So all these things are very important, where we need to focus. Diagnostic tools, that is the biosensors. I was just seeing that one of our paramedical science people, they are going to hold this biosensors conference next month, in the month of November. So the biosensors, green economy, ethanol production, that I have already discussed. I have told you that not only the Saccharomyces cerevisiae, but the new strains of the Gymomonas and alpha proteobacterium, they are now being used for the high production of the ethanol in the industries. So the new strains, they need to be developed, and that is the work of the biotechnologist, microbiologist to develop. This is just one of the flow diagram of the microbial cells production, which I told you that by 2050, we will be having the microbial foods. You will just use 1 or 2 tablets and you will get the entire energy for the whole day and just relax. I tell you that when I was in Manchester in 1985, in 85, long back, that is about more than 35 years or 38 years. During those days, there was a era of the genetic engineering. Everybody was saying that we will transplant the genes of the nitrogen fixing bacteria into the wheat, and then we will not require the fertilizer, chemical fertilizer to supply from the outside. I was a young boy in 1985, and I gave in the roundtable conference of the IUMS Congress, when then I was selected as a member of the advisory committee during that conference. I said that, why not you transfer the genes of the chloroplast in the man? What will happen? That the man will be slightly green. Instead of the hair, there will be some plant leaves. Whenever he will have hunger, he will go outside the sun. The food will be synthesized. Food will be synthesized, and the entire problem of the world will be solved. All the problems of the world are because of the energy what our stomach need, and when the energy will be automatic, then yes, I must congratulate Sangeeta that she will do it one day. But you know that the problem is when I was in the next conference in Israel, where now all this fight between Hamas and Israel is going on in 1994. Then in that case, many of my colleagues who were already present, I had criticized. I said that you can transfer the gene, but whether they will expression is a problem. Whether they will express. So expression is the issue. The transfer of the gene is fine. You can do it. Now you know the CRISPR technology, design babies, so many things are now available in the market. And this gene technology will change the entire scenario of the agriculture in the next 30 years. Green economy, there's a vinegar and many other productive products from the agriculture. They are being focused, and the industrial production of the biomolecules, food grade, acetic acid, citric acid, organic acid, several acids, say they are all the microbial products. They are all the agriculture products. Now you know that the microbiology or the microbial system what we are using, this is also a part of the agriculture. This is also, dairy is part of agriculture. Fishery is also part of the agriculture. Agriculture means the production of the food substance. Now the definition of the agriculture is the productivity. Production of the substance which are utilized by the man or human or by animals. Nutrients. Production of the nutrients. That is the definition of the agriculture. I do not know that how many of you are from the agriculture. Agriculture is going to play a big role. in the next few years. Agriculture, biotechnology, microbiology, these life sciences, there will be a big role of these people who will contribute to the economy of the world. Organic acids, several organisms I have given it here. I will leave this slide here. Maybe the Sangeeta and the Renu, I will give this slide. So all these students of the BSc or MSc or the biotechnology, microbiology, agriculture, they can use, this will be one of the crisp information for you to prepare for your examinations, to prepare for your competitions, to prepare for your projects, to prepare for many of the things. So these are the several acids what we can produce. I have given here the microbe which is used, the representative use, and the fermentation conditions what we can use. The green economy microbial fermentation, the other products I have given here. The high quality microbial proteins, what we can produce and what they are having the advantages. The source low cost proteins. Nowadays you find that the health foods, they are very expensive. There are some of the companies which are selling the products at a very high rates, only a 400 gram or 200 gram, 300 gram of the packet for 3,000 or 3,500 rupees, and it cannot reach to the poor people. Now, when most of the people, they will start, the production is very less. The production of these components, the product which is sold for 3,000 rupees, the production is only 50 rupees. Only 50 rupees. You trust me. So huge margin of the profit. And now this margin can be reduced only when the young people will come as a startup. When they will start making the mass production, there will be competition. So there is a huge opportunities in this thing, the green economy, the single cell protein. And we don't need much of the facilities. The only thing is that we need the training. We need the training and we need the focus, and we can do the things. Primary, secondary metabolites, several components, microbial enzymes. These are the list of the microbial enzymes which can be produced by the different bacteria. Microbial enzymes again continued. These are minerals, even the minerals from the soil, they can be also exploited by the green economy, by the agriculture products, by using the microbial products. Microbial mining, bioethanol, cyanobacteria, algal production, that is a biofuel, spirulina, the single cell protein, and edible algae, bacteria, yeast. Many times you must be thinking that the bacteria can be eaten. Yes, the curd you are eating, this is the best probiotic in the world, and it is containing the bacteria, several types of the bacteria. The antibiotics, antimicrobials, lactococcal products, lactic acid bacteria. You know that this probiotics, the Yakult, which is very famous, and 11 products of the probiotics, now they are available in the Indian market. And one of the trial of the probiotics, it is going to be conducted in your Subharti Medical College also. Day before, 2-3 days back, Dr. Sunil Sehwal was here, and he has been granted that one of the product for trial over here. So we will be conducting that. So the grass, that is the major achievements in the last 50 years, what we have done in the last 50 years. You see, the life expectancy, what we need, this has increased. It has doubled. If you see, before 50 years, in 1960s, 70s, the life expectancy, it was 35, 40 years. And now in India, the life expectancy is 70 to 70 years. So it is not that we have not progressed. We have progressed well. We have done well. But the only thing is that the population of the India is so huge that whatever the achievements we get, these achievements are distributed in 1.42 billion people, and the net result comes, ratio in terms of the ratio, it comes minor. So that is the one thing. 1 billion are obese while less go hungry. This is one of the achievement what we have done. Many of the people are fatty and many of the people are hungry. So this is the unequal distribution of the food. This is our achievement, unequal distribution. Do you think that this is achievement or this is the drawback? What is this? Tell me. Achievement or drawback? Drawback. So you know that is the distribution of the food that we need to change. Less die by war and violence than suicide. You are seeing that many of the people, they do the suicide, the mental health. This is our achievement or the drawback? Drawback. So this is, but I am saying that this is what we have achieved during the last 50 years. That is, we have increased, we are having this increased tendency, and that we need to change. Everyone in the world has mobile phone. This is our achievement or drawback? This is a nuisance. This is a nuisance, but the necessary evil, I can say it. Necessary evil. And what we need in the next 50 years, we need to increase the life expectancy, health for all, no poverty, quality nutrition, technological war that we are going on, electric car for everyone, technology-based economical dominance, more awareness towards environmental life possibilities in space. This is that what we are expecting. The India is what we are expecting in the next 50 years. So I think that that was my last slide. So thank you very much. I think that taken more time. So thank you. If there are any questions or doubts or clarifications, it will be my pleasure. Are there any questions? Or you didn't follow my lecture? Or are you having any inhibition? और आपके टीचर ने आपको कह दिया कि पूछना मत कुछ भी, डरा दिया है, धमका दिया है? नहीं. Okay, so best of luck. If there are no questions, I will come sometime to your department and then we will discuss and we will focus on the points of the next generation. That is what our next generation needs. Thank you very much. Thank you.
Thank you so much, sir, for such an informative lecture. Now I would like to request Dean ma'am, Dr. Sangeeta ma'am, Dr. Amit sir to present certificate of honor to Professor Dr. Amar Prakash Garg sir.
Thank you very much, but I think that this was...
Now, I would like to call our next resource person, Dr. Shri Prasad Vista, who will be connecting with us through online mode for his lecture session. Sir is adjunct professor at Himalayan College of Agriculture Sciences and Technology, Purvanchal University, Nepal, and Institute of Agriculture and Animal Sciences, Tribhuvan University, Kathmandu, Nepal. Sir is focal person of Nepal Seed and Fertilizer Project, funded by USAID and implemented through CIMMYT Nepal. Sir is regional coordinator of Asia Impact Youth Sustainability. Sir is coordinator of International Association for Promoting Geoethics in Nepal section. He is editorial board member of Soil Atlas of Asia FAO. He is editor of 13 journals. Sir has been awarded with Global Soil Scientist Award 2023 by ATDS India. Sir has been recognized as Most Outstanding Principal Investigator 2023 by Asian Food and Agriculture Cooperation Initiatives RDA Korea. Now, sir, this online session is all yours.
Namaste and a very good afternoon to everyone. So this is Sri Prasad Vista from the land of Pasupatinath. So I think, is it shared? My slide is shared? Yes? Okay. Is it visible? Am I audible? Excuse me. Am I audible? Am I audible? Hello? Is the screen visible? Hello? Hello? Shall I start? Shall I start? Hello? It's not, I cannot get any response from you, please. Yeah. Is it audible? Am I audible? Am I audible? Okay. I think I can share the screen. Share screen is visible, I guess. Am I audible? I cannot get any response from you. Okay, okay. Okay, if everyone can see me, okay, it's okay. Now, welcome you to my presentation. It's on digital soil mapping, and you might be knowing that Nepal has launched digital soil map last year in the year 2021, and it has been revised in 2022, and we could cover all the 77 districts of Nepal, and we have 30,548 soil profile data, and based on those data we produce the map. So before I start what soil mapping is, I would like to say something about soil, because it's very important, as Dr. Dilfuza has also said about it, and even Professor Garg, he mentioned about it. So soil is the foundation of all forms of life on earth, So when I talk about Nepal, it's a land of immense beauty and diversity, with very much having intrinsic cultural relationship with the soil. Here, the cultures are well protected and celebrated. When we go deeper into the human consciousness, and cultures, we can find very interesting stories. Soil is considered as mother, and for the Hindus, we can find very, a very good evidences like Panchatattva is the universal law of life. Everything is composed of 5 basic elements, and these are Akash, Vayu, Jal, Agni, and Prithvi. That means Prithvi, soil or earth. So our body, including the human body, everything, as I said, is composed of 5 basic elements. So our body is also a part of earth. That means soil is one part of human body. Even in the Judeo or Christian tradition, the first 2 human beings on the planet Earth were Adam and Eve. The original meaning, the name Adam translates to earth or soil. The meaning of Adam is soil, and Eve means life. This means that the imagery portrayed is that human life
Adam is soil, and air means life.
there is
This means that the imagery portrayed is that human life Adam is soil, and air means life.
it even gets deeper. It even gets deeper with the term human, humanity, human being. These are rooted in the Greek word humus, the fertile black top soil. While we use the term soil or word soil as derogatory term, we literally define ourselves as soil. So soil is habitat of all living things on earth. Soil functions, it has so many. So I think healthy soil, healthy water, and healthy air will lead to the healthy life. So when we are also talking about the sustainable development goals, soil directly contributes to 8 sustainable development goals, and we have 5 other goals that soil supports indirectly out of. So 13 sustainable development goals are addressed by soil. You can see that soil, as I said, is a habitat for all living things on earth, and it is also a source, or it has to be, it is the central of all global challenges. Soil is central to all the global challenges. I can show you with another slides where you can see that soil security is at the central point. There water security is there, food security is there. Without good soil, without healthy soil, food production cannot be increased. Food security cannot be imagined. So if there is good soil, production will be increased. If the soil is very good, the soil acts as a natural filter. So the water will pass 99.9% of the water which we recharge is filtered by the soil. If the soil is very good, in that case that water can be reused, otherwise it is very problem. So soil also act as a it can sequester carbon. So it also works in climate change mitigations. So there is also ecosystem delivery, ecosystem service delivery. It also plays very important role. So we have to make our soils very much secure so that all the global challenges of food security, water security, impact of climate change, energy sustainability, and biodiversity protection could be faced very easily. Soil is very diverse and very heterogeneous. It's a common issue everywhere. Every step, when you can see this, a farmer is plowing and his wife, she is sowing the seed here in the photographs. But each step, if you see the soil properties, it varies. There is very much heterogeneous. There is heterogeneity in color, even with the land use, even with the climate, and there are so many things which we can see. So in such conditions, if we collect soil samples and if we analyze it, you may not get the exact value or exact result, because the soil what we have is not homogeneous at all. So in this case, we have to go for digital soil mapping so that it gives some predictions. Digital soil mapping, is very, very up, is a burning issue now. Is soil properties have a very significant influence on crop growth as well as in yield. And in Nepal, if we see, the access to soil testing facilities by the farmers is very scarce. It's very difficult for the farmer to know the fertilizer requirement of their own land. The absence of developed soil information system and the different soil fertility parameter maps we don't have. And now with this digital soil mapping, we could prepare very easily. And this is also, we produce this in order to support the farmers and government, also to all stakeholders, to design some strategies for soil fertility and fertilizer management to improve crop productivity, also to estimate the total fertilizer requirement in the country, and also to correct the soil acidity. And in order to get this all information, we have produced an interactive digital soil map that provides access to location specific information. I'll show you, demonstrate you now on soil properties that gives the information across the whole country. So it provides information on soil type and nutrient deficiency, which is essential for the recommended fertilizer dose, and also to optimize the crop yield. It can also be used as an input data to estimate soil nutrient supply and develop a domain-specific fertilizer recommendations. Now, digital soil map is the prediction of soil properties using advanced machine learning tools based on the quantitative relationship between environmental covariates. This is just the soil forming factors and measured soil value. It may be very difficult to show you how what it is, but the thing is very simple. You can see that there are training data. These are the data from where we take the soil samples and we analyze in the lab, and based on we fit it in a prediction model, and we also overlay those training data with the covariates, because these covariates we considered in Nepal, we considered 168 different covariates, and with this we put it in a predictive model. We use random forest and we go for soil mapping, and this is how we prepare the soil maps. So if we see the initiatives, digital soil mapping, who has done, how they have developed, then globally, ISRIC has prepared one digital soil map for whole the world, and they use 230,000 soil profile database. And regional, if we see Africa, they made African Soil Information Service is there. So they made for the whole African region, and they use 85,000 soil profile data. And even for national, if we see India, in few states they have started, but they could not do for the whole. Even India cannot do. But Nepal, we have done with, I said, 30,548 samples. Since the country is very small, the prediction is very high. The prediction and accuracy is very high. So now I'm talking about digital soil mapping of Nepal. We prepared this digital soil map of Nepal and launched officially last year by the Prime Minister of Nepal. This year, during the World Soil Day 2022, we launched it, we revised it, and it is now we have the revised digital soil map of Nepal with 30,548 soil data, and we covered all the provinces, all areas. So the process of developing digital soil map, we have to collect soil samples from different sources. If somebody has, supposing in India there are so many universities, so many ICR stations, even if they have done, and that data can be gathered, and that data can be used for preparing the digital soil maps, and that has to be overlaid with the some data from remote sensing data. We can use that, and that has to be overlaid, and regression is being prepared, and that after the regression matrix is prepared, we have to fit it to the prediction models. The prediction models, what I said, is random forest, and we use a random forest, and generally people in everywhere they use random forest, and that model, that if the prediction, after prediction, we have to go, we prepare the maps, then we go for accuracy assessment also, whether that the result the model has given is valid or not. We have to validate those data in the field itself again, so that if we do in that way, it gives very clear message. And I said we use environmental covariates, and that covariates 168 covariates we used, and these are some of the areas from where people can get benefits from these digital soil maps. Policymakers can get benefits. I think I must stop this presentation here, and I should demonstrate the other part. I think if it is visible, please let me know from you. I'm switching to the other side. I'm switching to other side of my presentation. The entire screen, I think, is it visible now? This, is it visible? No. Wait. How can I? I think I'm going for other purpose now. Okay. Is it visible now? Is it visible? No. I'm not interested with the slide now. I think I'm planning to show you something. I'm going to
No,
Google.
sir.
Is it Google? Do you see this Google? I'm planning to show you something.
Sir, we are still in the slide.
No, sir.
Is it Google?
No, sir.
Sir, we are still in the slide.
Yes. Yes. I want to go to the Google.
Okay, now you can come on the Google. You come on the Google. Now you can. Yes, now you can share. Yes, now share.
I shared
Here
it.
it is. Yes, here.
Is it? I cannot do this. The other, I have 3 windows there. The other one, new tab. I just wanted to go to the new tab. I want to go to the new tab.
just wanted to go to the new tab. I want to go to the new tab.
This is quite
He
difficult.
wants to go on the new tab first.
Sorry, I think there is some problem.
So, he wants. Sorry, I think there's some problem. You wanted to show the map which you prepared.
Yes. In the
Yes,
it's
Google
completely online. So I just wanted to show that. So that. Mhm. No, I don't know how can I go. Anyway, just let me let me present it like this. No problem. Yes, sir. Yes, sir. Yes, sir. नहीं ये तो यस मैं तो ओके 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 Is it okay? You can see the National Soil Science Research Center. Okay, now we are in the so if it is like this, yeah. So okay. So I went. If it is okay, then I said here we have developed the digital soil map. It's completely online. So this is you have to click soil.narc.gov.np. So if we go to this website, you'll see this National Soil Science Research Center where I'm working, where I am the chief of this research center. So here there are two options. You can go to the maps here, soil map here, or there are in the lower button also you can see soil map. Click here to view. You can click here to view the soil maps of Nepal. So if I click, it comes like this. So I think it is visible. So it's online, so it comes a bit slowly. So the other in the left side button you can see that it is map plus. So it if you want to increase the size of the map, you have to click to the button map plus, then minus is to minimize the size. This is zoom to extend. So these are the layers where we can see now this the map of Nepal. You can see that if I click soil pH, it gives the soil pH of the country. So there are in the right side there is legend soil pH. So the red means very high acidity is there. So it's less than 5 pH. So in the eastern part of the Nepal, you can see that these are very red in color. So high acidity is there. So even the policy makers, this type of map is very much useful for the policy makers and even to the extension agents, extension workers, because if they see the policy makers, they can make some plans, policies on soil acidity management in the eastern part. So based on this map, the policy makers can prepare those types of policies in eastern region. And even if there is high high pH, the reclamations like subsidy to the farmers on gypsum or something like that, they can make policies on that or programs. So another map is soil organic matter map. So we can see the soil organic matter, where it is, how it is. So these types of map you can see. So we have here around 10 maps. So I'm going for zinc. Just this is the zinc map of Nepal. In the lower belt, the zinc is very much deficient, critical. In the higher altitude, is okay, it's high, but it's critically low in lower belt. So like this, we can prepare the digital soil map. This can be used as a decision making tool or for formulating some policies and programs by the government. So these are very much useful for them. But for the farmers, if we see that what they will be benefited if they get the whole map of Nepal, it will not be benefited for them. So there we have in the top we have all province. So a farmer can get information of his land instantly. If a farmers of province number 1, supposing I click to province number 1, he has to click here the district. Supposing I click Jhapa district, and there are municipalities. These are local municipalities. So even rural municipalities, everyone can see very easily. So I click a municipality, Haldibari municipality. So where this is the Haldibari, so it comes very clearly now. So only one small municipality has come. So this, and you can very easily see that in the lower portion this is the forest area, the other one is agricultural area. And we have in the left side, if you see, there are two maps. One is OpenStreetMap, the other one is satellite map. Now the map which I am showing is OpenStreetMap. Now if I click the satellite map, then it will come, everything will be very much clear, and farmers can identify his own location, on house, on farm. So now I'll just try to make it bigger. I'll zoom it. So if I zoom, a farmer can very easily understand where his land is, where his location is. But it may take a bit more time because of internet. So there are other buttons too. These are drag and drop functionality, GPS. Well, you can export the map when the map which I have shown earlier, like the pH map, nitrogen map, phosphorus map, those maps can be very easily exported. So this is a point analysis data, the other one, and here you can see the linear distance measurement of just wanted to see from one place to another how much distance is there. This is polygon analysis. Oh, it takes a bit more time anyway. So I'm searching for okay. These are the, yeah, this is one of the place where I was searching. So so supposing a farmer, he can very easily see his place. He can identify from Google Map. So he can also put his GPS location, and easily he can get the information of where his location. So after getting the location, supposing a farmer, he wants to know his land, the soil test values or soil properties of this land, then he has to go to this map, this point analysis data. Here he will click, and again the place where he wants to know the soil properties here, supposing. So if he clicks here, then the whole soil information comes like this. So these are the coordinates. The parent material is fluvial, pH value, pH, organic matter, total nitrogen, everything comes. So this gives the information of this area, of this plot. So it's very easy that this is what we have, the digital soil map of Nepal. So it is very easy for every farmers to know the soil profile. So this, even this can be the data can be exported. The data can be very easily exported. Suppose again I want to know this area. So this you can see that it gives information for all those parameters. And there is one thing, export to CSV. If I click here, it goes to CSV, and it will give you the data will be in Excel file. So you can very easily download it, you can save it, you can print it, and you can give it to the farmer. Supposing there may be a big company who own around 500 hectares, or maybe there are some other companies who wants to go for organic farming in certain areas. Then they may need soil, soil properties of bigger area. So in that case, what we do is we can go for polygon, this area, this polygon mapping, polygon analysis. So if I click in this polygon, then I can make a polygon in that area. Supposing this much area I want, supposing this much area. So this is one polygon. So it gives, if I click like this, then the information for all these polygons come out like this. This is the soil pH value. This one maximum, minimum, 5.5 maximum, minimum is this much, median, mean, median, it comes like this. Organic matter, everything it comes. So it can also be exported. So there are other soil deficiency. If there is some deficiency, no, 0 hectares, there is no deficiency of organic matter, total nitrogen, or even the zinc. So nothing, no deficiency is there. So the company or the bigger farm, they can also use this data in this way. So it's very much useful to everyone. So if I think my time also is very short. Anyway, my suggestion and my my conclusion is that even this has been done by Nepal, and Nepal has done a very good job, and everybody has appreciated us. But this can be replicated, or this can be done by even India. So I think India is a big country. They have thousands or lakhs of data everywhere. If they can compile those data and make good mapping in this way, then all the farmers will be benefited. Not only the farmers, even the traders, even agrovets, business personals, they can also be benefited. Even the companies, fertilizer producing companies, there are so many companies in India, they can also be benefited, because they can see how much fertilizer may be required. So based on the soil test values, fertilizer can be fertilizer dose can be updated. So everything, it is very useful. And this is one of the digital soil map is one of the most important decision making tools for sustainable agriculture. So this is what I wanted to share with you. Thank you very much. Thank you. Thank you very much. And if somebody has some questions, I can answer those questions now. Hello.
Such an informative lecture. Now the lunch is about to serve, so all dignitaries HODs, and faculty members are requested to have
Thank
their
you very
lunch.
much. And if somebody has some questions, I can answer those questions now.
And I summarize the lecture of Professor Sri Prasad Vista. You know that in Nepal, it is the first country in the world which has digitally prepared the map of the soils. Map of the soils, not only for the pH, but for the minerals also. Although Nepal is a small country, but the efforts of Dr. Vista have been appreciated by the entire world. And Nepal is a first country. And you know that last time when we were discussing, when he was here as a visiting professor in one of the conference, then we were discussing, and some of the people from the IARI, they also wanted, because India is a big country, and India is also having the same data about the soil pH, about the zinc, about all the nutrients. We are also having the data. But the question is that we are not preparing such type of the system. And this type of the system, you know that it is helpful not only for the farmers, but for the entire country, businessmen, for all these things, and it will help the natural agriculture to grow in a sustainable way. And that type of the system, we need to prepare digital maps of the soils. We need to prepare for the entire world. Not only the digital maps of the soil, but we need to prepare the digital map of the air also. As Professor Vista said, that the healthy soil, healthy air, healthy water will give you the healthy life. Healthy life. So this we need, and whenever Professor Vista will come, then come to India, then we will ask you people to interact. So thank you, Professor Vista, for giving this wonderful lecture and the wonderful presentation, and best of luck for your research from the Swami Vivekanand Subharti University, and thank you very much for joining us on this platform. Thank you very much. Thank you.
Okay, I'm making this announcement third time. Now the lunch is about to serve, so all dignitaries, HODs, and faculty members are requested to have their lunch. Students, you have to wait for a few minutes. Just for a few minutes. deans, faculty members, and students on behalf of Keral Verma Subharti College of Science. Deans, faculty members, and students on behalf of Keral Verma Subharti College of Science. Dr. Vinay Chakravarti sir will still resume his lecture as we are trying to connect with him. Dr. Vinay Chakravarti sir will still resume his lecture as we are trying to connect with him.
Share, 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 share. Share screen. Share screen. Yes, yes. It is visible. It is visible. Do you hear me? Please. Do you hear me? Hello? 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 Hello?
Yes, sir, we are able to
Hello?
listen you.
Okay, okay.
Hello? Sir,
Hello,
you are
can I start
audible.
now?
Yes, sir, we are able to listen
Okay,
you.
okay,
Hello?
okay.
Sir, you are audible.
Uh, I want to again start my PPT presentation. Thank you all. Good afternoon to all. Welcome to International Conference on National Agriculture for a Sustainable World, organized by Kerala, Verma. That is Subharti College of Science, that is Meerut, India. I am very happy to participate with this online conference. If it should be good, if I present physically, then it should be good. But okay, thank you for give me a chance to deliver a lecture about the fisheries, that is aquaculture field of Bangladesh. My topics is aquaculture for sustainable, that is aquaculture for sustainable development. Actually, what is happening? This is the very important sector in my country. I shall. This is, we know that the United Nations 17 Sustainable Development Goals aim to achieve the decent life for all on a healthy planet by 2030. But what is, in case of Bangladesh, what is happening? Actually, fisheries sector is very much related with out of 17, that is goal 1, 2, 3, 6, 5, 6, 8, 9, 13 and 14. That is 1, 2, 3, 4, 8, 9 goal are anyhow linkage with fisheries and aquaculture sector. What is the condition of rank of Bangladesh? SDG rank of Bangladesh is 104 out of 163, and score is 64.2222. This is the findings of last year 2022. That is this is the. Now I want to say contribution of aquaculture or fisheries sector. Fisheries and aquatic resources provide a rule for food security, employment, profit, and save money. Why it is very important? Fish consist 15 to 24% protein, 1 to 3% carbohydrate, 0.1 to 22% lipid, 0.8 to 2% inorganic substances, and 66 to 84% water, and provide calories, nutrient. What is the nutrient? Fat, vitamin, and other elements. Fish protein is the better protein than that meat and poultry. So doctor prescribed fish for a patient. Fish production of Bangladesh last year was 4.76 million metric ton, and fisheries sector contributes. What is the contribution? 2.08%, that is of national GDP, 21.83% of the agricultural GDP, 1.05% of the total export earning. About, it is the remarkable, about 12% of the people of total population lead their life directly or indirectly on this sector. Fish alone supply per capita fish consumption of 62.58 gram per day in our daily dietary requirement is the burning issue, vulnerable issue, I think, because protein percentage, everyday protein percentage is the main one of the major issue for human health. Methodology, how the research were done. They developed a semi-structure questionnaires and collected primary data by focus group discussion, that is FGD, local ecological knowledge, LEK, and direct interview with the individual respondent, that is fishers, that is fishermen, fish farmer, transporter, piker, or other social worker, and other stakeholders. Secondary data was collected mainly from the Department of Fisheries and review relevant literature and online. Data were analyzed one way ANOVA and using SPSS system. Now I want to say about the aquaculture sector of Bangladesh. What is happening is there in Bangladesh, inland open water bodies, that is capture water bodies and its production scenario. Total, here is the total area, that is 3.917 million hectare total area. It includes river, estuary, Sundarban mangrove area, Bill, Kattai Lake, wetland, floodplain also, and the total production is 1.3012 million metric ton. What is happening in culture? In culture water, what is happening? The total area is only 0.80 million metric ton, but 180 million hectare is the volume, and the total that is it is supporting water bodies are ponds, seasonal cultural water body, bower, stream, prawn, farm, crab, pen culture, and case culture. But this is the out of three, this is the highest contribute the highest production. That is 2.638 or 64 million metric ton. It is very remarkable. And in case of marine, what is happening? In case of marine, it is happening. Only coastline is 710 kilometer, but marine production is 0.6812 million metric ton, and total production is it is wrong, 4.67 million metric ton. While enrich the fish biodiversity, what is happening in that case? Freshwater species number is 260, and out of them now 31 species are going to extinct. Freshwater shrimp species is 24, exotic fish species is 23, not 12. Marine fish species is 468, marine shrimp species is 36, tortoise is 22, crab is 12. Out of 12, 4 crabs are very economical importance have it. And in case of what is happening in case of seasonal production of natural spawn production, riverine production. Once upon a time, aquaculture practice was demandable to natural fish spawn, but nowadays it is very burning issue to get the natural spawn from the that is river, floodplain like this. What is happening? The graph is shown what is happening there. The production increasing, decreasing, increasing. Why it is happening? Due to climate change, man-made created problem. What is the problem? That is siltation, pollution, over exploitation, that is collection of fish fry from the natural resources, and indiscriminate use of pesticide and heavy metal also. What is happening in that case? The production of natural spawn, artificial spawn, it is ongoing smoothly, and nowadays it meet up the demand of production of our artificial spawn. What is happening in case of total production? This is the graph of total production. That is 1983-84, the production was only 0.75 million metric ton. It is increased day by day, and in mid-time 1.89, that is 2001 to the production, and last year is 4.769 million metric ton is the production. Is the marvelous, I think marvelous increasing or developing the aquaculture production of Bangladesh. Okay. Here is the contribution inland capture fisheries. That is, I want to say the open water, river, floodplain, bill, gill, like this. What has happened? 1983-84, it was the 0.47. It was last year. It was 1.32 million metric ton. But what is happening in that case? Here, 1983, the open water fisheries support 62%, and 2007-8 is support 41.41, and last year is support only 27.55%. Why it is happened? I shall tell it later. In case of the production of river and estuary, it is increased due to several problematic issue of related subslide of production. And every sector we are trying to increase the production of open water. And what is the contribution of inland total culture fisheries? Culture fisheries, it is very remarkable. You can see 1983-84, the production was only 0.12 million metric ton, but it is increase. Last year, it contributed 2.73%. It is very remarkable contribution in inland close water body. But what is the contribution, percentage of contribution? 1983-84, the percentage cover only 15.53%, and 2007-8, it contributed 39.22%. Last year, the contribution was 58.34%. It is very remarkable for the aquaculture sector of Bangladesh. Production of pond, it is what is happening 1983, 87, it is only 0.11. Last year, the production was 1.1 or 2.17 million metric ton. Very remarkable production. Now I want to, now I want to say some other sector, that is production of crab, how it's contribute. This is the line diagram of the crab. Here the production percentage is increasing, decreasing last year, that is 16, 17, 2000, but it is increasing trends. In case of pen culture, what is happening? It is practice 2003-4, decrease, that is 2014-15 decrease, and it is increasing nowadays. In case of case culture, it is decreasing. Marine total, what is happening? Marine total, actually marine total, it is capture. Just it is catch statistics. It is also increasing day by day. Last year, the contribution was 0.71%. And what is happening? The contribution of percentage. 1983-84, it contributed 21.88%, but last year the contribution was 14.11%. And now, how aquaculture contribute in my country? There are some technologies we use, extensive method. We are producing not less than 1.5 million metric, not million metric ton. Semi-intensive 1.5 to 4 metric ton. Intensive 4 to 10 metric ton per hectare. And highly intensive we are produce that is 10 metric ton. Aquaculture. We are practicing carp polyculture, small polyculture, catfish polyculture, monoculture, case culture, pelican fish culture, pen culture, integrated fish farming like this. This is the fish we are, this is our Indian method carp. We are practicing in polyculture of our aquaculture. This is the fish which are that is exported from different country, that is pangas, big hair, silver carp, grass carp, black carp, common carp, Thai shore putti, tilapia, like this. Nowadays we have some so many important native fish. Native fish, that is what is happening in case of diversify indigenous fish. Some fish, that is the very delicious fish, highly proteinous. We are, it is that is we are just induced breeding, nursing and culturing. In case of Mr. Cavias, this species also, and Mr. Stangra is also, and Heteroportia fossilis also, and Cladius batracus also, and Anabas testutinus also, and Chana striatus, that is striped snake hatfish also, and Amliferin mola also. It's a very important fish. It is the resource of vitamin A. This is the best medicine for eye, baby's health. It is a support of vitamin A. For that reason, this fish is very important in the aquaculture sector in everywhere of the world. And this is the fish of that is not chitala. It is an important fish. It is also culture, breeding, nursing and culturing. Here there is a fish. This is called Pangasius fish. It is exotic fish, very important fish. It contribute 8.53% of total production. Huge amount of pangas is produced in my country. In case of Nel tilapia, what is happening? Its contribution is also 8.54%, and this is the production. The production is increasing like pangas. And now culture of some other fish, that is the Kuchia. This is the culture practice is two type. Aquaculture method, this is the method. Natural resource management system, this is another method. We are the two culture technology we are used to produce this species. It's a very important fish species. It is for medicinally fish in the aquaculture sector. It remove for the disease of that is it is a create the blood cell of the from blood circulatory system. It is a medicine for diabetes. It is medicine for so many disease. This is cure. So it's a very important fish. And develop the three technology of crab culture. That is, it is very important. It is exported every day from my country in East Asian country, also this is European country. Juvenile culture, it is a technology. Crab fattening culture, actually crab fattening case in we are practicing now. That is our we are this is the practice of natural fish farming, that is agri-based fish farming. Fedicam fish culture, it is treated the perimeter type. It is the Fedi grows in the middle. This is the middle inside the round side is water, and it is a very a good technology for Fedicam fish culture practice. As a central pond culture, inside the Fedi land there is a water. So it is also a good technique. And lateral trans system, this is the system just like a triangle, one corner of a triangle size we are practicing. And what we are practicing? We are practicing the major carp, chana species, tilapia, seeing magur koi like this. And total production is counted 2 metric ton, that is 2000 kg per hectare. And what is happening in horticulture cum fish farming? This is a very good technology for that is natural fish farming. We are producing fish, we are producing fedi, we are producing vegetables, we are producing so other agricultural products. Fruits and vegetables contain research has recommended 85 grams of fruits and 300 grams of vegetables to consume daily for a person. So one family can easily produce his required production, and excess production is going to sell in the market. Livestock farming, this technology is totally banned for safety of food, because direct poultry litter is dropped in the pond. It is not allowed. It is created some disease for human health, fish and human health. Duck and fish culture on the dike of the pond, there is a farm. They are like this. There are some dike, the duck. What is the about 300 to 500 number of duck per hectare, that is Kagi Campbell, are reared in to fertilize 100 hectare pond. This is the one issue. The duck acts as the liberator. It creates some oxygen in the water, and total production is that is 3,500 to 5,000 kg fish, and 18,000 to 80,500 eggs are produced, and 600 kg of duck meat produced 1 hectare. This is an important issue. And this is the another issue that is called cattle cum fish culture practice. It is also a good technology. Cow shed should be built close to fish pond to simplify. That is handling of cow manure. A healthy cow may excrete over the 4 ton to 5 ton cow dung. This is used in pond for fish culture, and about 5 to 6 cows can provide adequate manure for 1 hectare pond, and in addition 9,000 kg milk and about 300 to 400 kg of fish produced from the fish annually from 1 hectare pond. Another issue is bifloc fish farming. It is another issue. It is a very modern technology, but it is not sustained in my country, India also. So I am not so interested in this method. But this is another method, that is bottom clean raised water pond. We are producing 10 metric ton per hectare. It's a very good technology. So the people are now interested to abide by this technology. Here, you know that some important fish, Tenusa Ilisha Hilsa fish. From producing Hilsa fish, this is the Bay of Bengal. From the Bay of Bengal, the coastal area of this, there is the Magna River, the belt of Magna. Here is the breeding season. There are 6 color here. 6 color is declared as a 6th century, and activities should be run whole the year in this site. And nowadays, no, every year in October, March, 13 days are totally stopped to catch the Hilsa fish from the river due to its breeding season. Here the scenario of the producing of Hilsa fish, it is increasing day by day. Last year also it is increased. So we are hoping if we manage the management technology of Hilsa fishery from the some rivers, it should be increased, and the population of Hilsa should be also increased. Floodplain management, we manage its 2 ways. It is stocking of here is the scenario, stocking of fingerlings in the wetland. It is the one way to improve the productivity initiative, releasing fingerlings, that is 48,994 metric ton fish fingerling were released, that is 2002 to 2021. At the time, the production was that is extra production 0.045 metric ton hectare annually was produced, and some endangered species reappeared in this sector. And here is the another issue: the establishment of Bill Nursery. There is a open water in the dry season. We practice in some nursery field in this area, and we started for nursery. After producing so many huge of fry and fingerling, it just automatically released in the open water. This is the another system. Total production in the Bill Nursery were that is 16,298 metric ton, and as well as extra fish production was increased, and endangered fish species is reappeared. And established on a Bill fish sanctuary, it is a river or deep water. It is practice fish sanctuary. We that is the there are 432 sanctuaries in my country, and protect and conserve the fish from the extinction and save the status of aquatic biodiversity. And for some endangered species like titol, foley, koi, calbaut, these are reappeared in this technology when we are applied. Fish habitat rehabilitation is another technology. This is the dry river. We in the dry season we try to re-excavation the pond, and with forming a community management policy, and it is a good way. And here is the natural breeding ground, that is Halda River. I discussed the first. What is happening? There is a very poor amount of spawn is found in the river system of Bangladesh, but there is a river in the Halda River. It is situated in the beside the Verma and India. We produce the genetically improved spawn in this river. So we have to anyhow we protect it. We collect the spawn and rear in pond and as a brood fish of as a brood. So it is a very important issue. Extension of pen farming. This is the scenario. The water body is protect this area. We practice here. We that is total fish production was increased 0.132, that is 1.142 lakh metric ton. That is the last year. Here there is a practice of case culture in potential water bodies. It is ongoing smoothly. We are producing. The result is production result is was shown before. This is CBFM technology. We know that there is a technology. There are huge amount of open water bodies and depth water also. We first of all that is about 411 hours in the area of 8,000 square kilometer. where we cover 25% only in Sunamganj, Maulibaza, Sylhet district only. It is a very technology. The water body is managed by the communities people. They protect the water body. They produce the fish naturally. They harvest the fish partial. This system is very important for fishermen management ID card. Every fisherman has a ID card. This system is developed before 5 years ago or 6 years ago. Now, I think it is a good issue to identify a fisherman or a fish farmer easily. And traceability. Traceability is another issue. The person who catch the fish and sell the market and export to the foreign country, if there is something wrong in the fish, then it should be identified. It is a tagging system. It is a mark system. So traceability is a very important issue for aquaculture sector for safety food. And Fisheries Diploma Institute, I basically me himself, I am the founder of this Diploma Institute. Mid-level fisheries manpower is created in our country, and they are employed in the fisheries sector. They're working. They're working now in the fisheries field. So I am proud of them, and they are contributing good contribution for the country. And helpline disk. There is a mobile online system where farmer when face any problem, he contact directly our departmental officer, there are scientists, and they can advise the farmer easily at that time. So this technology is not only for aquaculture, it should be used, it should be applied in case of agriculture, livestock also. It's a very good technology. Here, world population is, we know that 2050, the population of the world will be 9 billion. So it is a burning issue. It is not easy to meet up the dietary demand of the huge amount of people. It is a great challenge to meet dietary demand. And we are facing so many natural calamities, just like COVID-19 and extinction. At this time, there are so many species are going to extinct. This is the issue. And for aquaculture management system, there is a issue. The structural intervention is a main issue. For it is very important for not only Bangladesh, India also. Very recently, the flood of Sikkim. There are so many barrages there. For that reason, there is happen of this kind of flood, and so many people have died before 3 to 5 days ago. And it is a very problematic issue for fish culture also. Before permanent construction, several studies should be needed and construct eco-friendly flood control and irrigation structure dam. And pollution is another issue. We know that we are suffering seriously from pollution, different kind of pollution. Annual emission Hello. 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 Hello.
Yes, sir, we are able to listen you.
Okay.
Hello,
Okay.
sir, you are audible.
Yes.
Yes, sir,
Ye-
we are able to
Yes.
listen
Yes.
you.
Yes. I want to. Okay.
Hello, sir, you are audible.
Okay. Sir. I am audible. This is the case I want to say about the agrochemicals. Agrochemicals in Bangladesh, 250 varieties of pesticides are used. It is a very burning issue. Use 48,690 tons pesticide yearly use and 25% discharging into the Bay of Bengal directly. Pesticides residues kill fishes. Enrich knowledge about the using fertilizer and pesticide contamination of aquatic habitat and prevention habitat. And plastic is a burning issue for our health also. It is known to us. Microplastic is also found in our blood and nature also. So total plastic 15,345 lakh metric ton daily in Bengal from 18 river of Bangladesh, which comes from Myanmar and India. About 2,519 metric ton comes from India. 284 metric ton comes from Myanmar. And control use of plastic for the save human being. It is a burning issue. The fish just cover the plastic. And over exploitation himself, over exploitation is another issue, serious issue to reducing the population of fish. Over exploitation should be stopped and mainly maintain eco-friendly catch from the water body. Lacks of institutional management, it is another issue. The main objective is revenue collection, so no post lease monitoring of wetland, managed leasing by the Minister of Land and opposed by the Minister of Fisheries. There is a contradiction between two ministries, so there is a problem. And leasing agreement should be implemented strongly and needs collaboration between the two departments. And advanced aquaculture himself is a harmful to aquaculture, because what was the reason? Increased use of antibiotic to control fish disease, and that is develop bacteria which is antibiotic resistance. Maintain fish feed acts and fishery acts in our country. Irrigation is also another issue. Irrigation resulted shrink the size and completely dry out, leaving no space fish in wetland. Excessive groundwater withdrawal has similar effect like this scenario. So we have to alert. We have to use the water eco-friendly for the production of paddy. Sedimentation. This is the picture. Change physical structure and biodiversity of the rivers and wetland due to increased sediment load. Sediments runoff. Sediment creates respiratory or feeding problem. A strong action plan needs to face sedimentation by the collaborating with the different ministries. And alien species, these are the 24 alien species are already exported legally or illegally. Sucker fish now cover, this species cover 2 or 4 river, Buriganga, Shitolaga, Tulak river, 90%. So it is a burning issue. Increased production, predation and competition, disease, habitat destruction, genetic stock alteration, and even extinction. Control exotic and alien species imported and apply Hatchery Fish Act. And effect of climate change, it is known to us what is happening and the effect of climate change. Aquaculture are vulnerable to flood, droughts, hurricanes, cyclones, storms, stratus, and erratic rainfall. Riverbank erosion, deeper penetration of saline water, and serious flood from the north. Intense cyclone that is bring disaster regularly. Change seasonally and productivity of plankton and food webs interaction. Effects on fish habitat, physiology, fish behavior, and that is the growth on that is reproductivity capacity. Change the breeding season, increase mortality and distribution. Sorry. This is the scenario of a flood 2022 in Assam and Bangladesh Sylhet region. This is the happen. No agriculture product, no fishery product, no even seriously affected livestock product also. So it is a burning issue. Another issue is when this year the temperature is increased in Bangladesh. The highly temperature is recorded only 42 degrees centigrade, but by this year it is recorded 46 centigrade, degree centigrade. For that reason, there are so many fish farms. That is basically shrimp farm is affected seriously. Conclusion. In conclusion, I want to say, ensure quality seed and feed production for feed for aquaculture, increase competition among land and water feed user, decrease it, controlling aquatic pollution and promotion of small scale low cost aquaculture for rural development, improve reduction and environmental impact through better site selection and use appropriate technologies and efficient resources. Support politician is very essential for a development of fisheries sector also. So democracy is a good democracy is very much essential. Need to support conservation organization to save open water, coastal and marine resources, and need knowledge-based research and management. What is I want to say finally? For development stages, strategic goals of aquaculture are what is one, social, enhance the health and well-being of the people through the production of nutritious food and secure livelihood. Secondly, economics, that is stimulate economic activities in rural communities, create more rural employment opportunities, increase income of rural. Hello. Hello. I'm sorry. Hello. 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 Hello.
Hello,
I'm going
sir,
to.
you are audible.
Sorry. Due to
Sir, we are able to listen you.
that's I want to conclude now. Actually, ecologically, it is promote the conservation of aquatic biodiversity, enhance of genetic resources, conservation of natural resources, and ecological resilience, and institutionally established and enhance the environment and develop the capability to effectively manage the sector, provide the support of service needed for sustainable development, and yeah, that is the what can I say? The finally, I want to say the four development statics goal of aquaculture is very important for the for livelihood, for daily life maintenance, and to earn money, export of export item, and it is a burning. I think it is a very important sector, aquaculture and fisheries sector of Bangladesh. So it can easily support, it can easily give positive sides of human health also. So I think this is my presentation. Thank you to all. Hello. I want to conclude now. Hello, Madam Ji. Hello.
Hello. Yes, sir, you are audible. So you can continue.
But I want to conclude.
Thank you, sir.
Yes,
sir, you are audible. So you can continue.
But I want to conclude.
Thank you, sir.
This is the aquaculture is basically support of social, economic, ecological, and institutional. So it's a very important sector. Hello.
Yes, sir. Sir, you can carry on.
But I want to. This is the last slide. This is the last slide. I want to conclude my presentation. Aquaculture supports socially, enhance the health and well-being of people through the production and nutrition of food and secure livelihood. It also support the economics, stimulate economics activities in rural communities, create more rural employment opportunities, create income of rural household, and the save and earn foreign exchange through export earning. Ecologically promote the conservation of aquatic biodiversity, enhance of genetic resources, conservation of natural resources, and ecological resilience, and institutional established and that is enabling that is environment and develop the capacity to effectively manage the sector and provide the support sources needed to sustainable development. So this is the this is my presentation. This sector is a important rule in our country, not my country, in our in England, India also, and Nepal also. There are so that is Southeast Indian countries also. So I think we have to anyhow increase the aquaculture and fisheries development system for the well-being of our economy, our health and economy also. So thank you to all. I want to conclude my presentation. Okay. Hello. বুঝতে পারতেছি না। Thank you to all. Hello.
Sir, you are audible, still audible.
Thank you to all. Hello.
Hello.
Sir, you are audible, still audible.
Thank you, sir, for this knowledgeable lecture on aquaculture and fisheries. Thank you, sir, for this knowledgeable. Okay. Now I request HODs Dr. Vinay Pamar sir, Dr. Arvind Sharma sir, Dr. Shashiraj Tevatia sir, and Dr. Aftab sir to facilitate our chief guest Dilfruza ma'am with memento. Now I request Dr. Sangeeta Dayal ma'am to honor Dilfuza ma'am with Patka. I request HODs Dr. Vinay Pamar sir, Dr. Arvind Sharma sir, Dr. Shashiraj Tevatia sir, and Dr. Aftab sir to facilitate our chief guest Dilfuza ma'am with memento. And I also request Dr. Sangeeta Dayal ma'am to honor Dilfuza ma'am with Patka.
All faculty of Science.
ग्रुप फोटो के लिए प्लीज आ जाए.
लंबे वाले पीछे मैडम इधर नहीं आएगा पोडियम हटा दो
बुला लो ना
और होंगे ना रिसर्च स्कॉलर प्रशांत का प्रशांत आ जाओ
मैम आपका ना फोटो सेशन का तसल्ली से करोगे जिससे ना
हाँ आराम से बस इसी हो जाने दो
छोटे छोटे से काम हो जाए फिर अच्छे से आप आओ जल्दी जाओ फोटो खिंचाओ
बेटा
नहीं सर थोड़ी देर पहले था नहीं सर था थोड़ी देर पहले अभी कर दूं Now, I would like to request Dr. Sangeeta Dayal ma'am, organizing secretary of this event, for vote of thanks.
Thank you so much. So, the golden words of gratitude is on the heart of guests, breathing hosts and guests in an inexplicable bond of love and concern. Jai Hind, good afternoon to all of you.
It is the most privilege for me to give vote of thanks on behalf of College of Science. First of all, Jai Hind to the Honorable Chief Patron, CEO, ma'am, present dignitaries, worthy delegates, and worthy faculties, and my dear students. I take it as the most opportune moment to express profound gratitude to the august assemblies of guests who look the glory of academic conference and share their valuable suggestions. It is a rare honor for the college or any university to host any international delegates in any event. So I would like to thank, first of all, I would like to thank our Honorable Vice Chancellor, sir, to give us a guidance to organize this event in a success way. Thank you so much, sir, for your suggestions and your guidance. Thank you so much. I would also give my gratitude, my hearty gratitude to our CEO, ma'am, for her love and affection and the motivational words to organize this symposium in a beautiful manner. Thank you so much, ma'am, for your blessings and wishes. Next, and the most important, I would like to give my gratitude for our guest, our now she's our own guest, Dr. Dilfuza Zebrova. I would like to express my deep gratitude to her for being here on this special occasion. Ma'am, your amiable company of such an erudite like you has lent to this event and has inspired the gathering of scholars to excel in their chosen domains. Your sage advice and valued opinion have certainly broadened and horizon of understanding of the representative assemblies and participants. Thank you so much, ma'am. Thanks a lot for your valuable words. Thank you so much. We would like to you be here again and again. So please consider our request next time also. Thank you so much, ma'am. I also thanks to Dr. Vinay Chakravarti for their wonderful and excellent delivery of his lecture and his guidance for the sustainable world. Thank you so much, sir. Yes, there was some technical glitches, but it is okay. For online, most of the online programs, it is happening here and there and all over the world, not only in India, all over the world. So please consider and thank you so much once again. Now I feel grateful thanks to Dr. Prasad from Nepal. His visionary words are most important for our scholars and for future scientific research also in life sciences. So thank you so much, sir, for your excellent delivery of your lecture. We would like to invite you as offline also. So please consider our request for next time. Thank you so much, sir. Now, I feel a great thanks to Dr. A.P. Garg, who is Dean Research. No. His direction, his guidance, and his motivational words are behind this event. So I always, I want to give a big thanks to Professor A.P. Garg, sir, and we want to be guide. We want to be guided by you in future also. So thank you, sir. I also wish to acknowledge the devoted endeavor of the organizing team also. Our teachers, our team, and other staff members, they all have striven talking time by the forelock and execute the assigned task for perfection and the extend hospitality to the participant and guests. My thanks is also especially for the registration team, refreshment team, discipline committee, and welcome committee for done a wonderful job and excellent job. Thank you so much. We in hope in future we will get your cooperation again and again for in every event. Thank you so much. I also give a gratefulness and congratulations to the ERP team and IT team also, because when we organize a event online mode, there are so many glitches faced by all the candidates, all the participants, and all the members of the organizing team. So it was manageable and it is managed now. So thank you so much for your cooperation, and we want your cooperation in future also. Thank you so much. At last and not the least, my dear students, thank you so much, my dear student volunteer also. Students, you have done a great job. You have done a remarkable job to maintain your discipline and your decorum of this hall. Thank you so much, and God bless you all. We wish कि हम और भी अच्छी ऑर्गेनाइज करें इवेंट और उसमें आप लोगों का डिसिप्लिन ऐसे ही देखने को मिले, because students are the remarkable mark of the any college or discipline. So when you will be disciplined, we already get success. Okay, so thank you so much. And without them, it was not be completed. Our presenters, Dr. Supriya and Dr. Ekta, who is not here now. So I give you great thanks for your continuous contribution and excellent delivery of programs. So thank you so much being with us, and God bless. All the best to you. Once again, I want to state that we are all most grateful to all speakers on this stage. We thank you for being with us with this evening. It has been a great pleasure. On behalf of Science College, I grateful to you forever, and I wish we will once again meet together in coming days. So we need your wishes and blessings. Thank you so much. Thanks a lot. Jai Hind, Jai Bharat. I think the program is concluded. So thank you so much. Thank you so much, ma'am.